Nothingness, the absolute void, is a concept that confounds the human mind. We tend to believe that for anything to exist, it must have originated from something. So how did everything begin? We often claim it started from nothing, but how can nothing transform into something? In the vast cosmic expanse, where galaxies glow and black holes consume matter, the concept of nothingness challenges our understanding of the universe. This is not just a philosophical idea, it is a cornerstone of cosmology that has intrigued scientists and thinkers for centuries. Picture a region of space devoid of stars, planets, or any matter, just pure emptiness. It resembles a quiet corner of the universe where conventional physics may not apply. The idea of nothingness seems contradictory, yet it is crucial in the study of cosmology and science. To understand the mysteries of the universe, one must first grasp what nothing means in the context of space. The emptiness of space might seem like a perfect vacuum, completely devoid of matter or energy. While this simplistic view holds some truth, it does not capture the complexity revealed by scientific discoveries. In modern cosmology, nothingness is not an absolute void, but a complex and dynamic terrain that defies our preconceived notions. Let us explore this concept through the scientific lens. Contrary to what one might think, the vacuum of space is not truly empty. It is filled with quantum fluctuations, where particles and antiparticles spontaneously appear and annihilate each other. These fluctuations give the vacuum a dynamic and ever-changing nature. Space is intrinsically linked to the fabric of space-time, as described by Einstein's theory of general relativity. Even in areas without visible mass, massive objects can warp space-time, influencing the paths of nearby objects. When we look into space, we can detect the faint echo of the Big Bang, the cosmic microwave background radiation, a relic of the early universe that reminds us space has evolved over time. Despite our advances, the concept of nothingness in space remains a profound puzzle for scientists and philosophers. There are theories suggesting the existence of regions in the universe where matter density approaches near absolute nothingness, though these ideas remain speculative. Some hypothesize that there could be areas in the cosmos with extremely low matter density, verging on voids. If such regions exist, they might provide essential insights into the nature of space itself. Is empty space truly devoid of all matter and energy? This seemingly simple question opens a Pandora's box of scientific and philosophical exploration. Traditionally, space is seen as a pristine vacuum, a barren canvas without matter or energy. This notion fits our understanding of emptiness, but as we delve deeper into cosmology, we find that reality is far more complex and intriguing than we ever imagined. In the realm of quantum mechanics, which governs the behavior of particles on the smallest scales, we encounter a concept that challenges our idea of nothingness, which is called as quantum fluctuations. These fluctuations suggest that even in the emptiest parts of space, particles and antiparticles can spontaneously appear, interact briefly, and then annihilate each other. These fleeting events defy our conventional understanding of emptiness, bringing a dynamic quality to the void. Additionally, Einstein's theory of general relativity teaches us that space and time are part of a four-dimensional fabric called space-time. Massive objects, such as planets, stars, and black holes, can warp this fabric, affecting the motion of nearby objects. Thus, the idea of a completely empty, unaltered space becomes an elusive dream. How does nothing relate to the presence of dark matter? And what does it reveal about the universe's intricate structure? To solve this cosmic puzzle, we must first understand dark matter itself. Unlike ordinary matter that forms stars, planets, and galaxies, dark matter is invisible to our senses and reveals its presence only through the gravitational forces it exerts. It represents the ultimate form of nothingness, eluding direct observation and defying traditional definitions of matter. Dark matter's existence was inferred through the observation of galaxies and their movements, as the gravitational pull of visible matter alone couldn't account for their behavior. To explain this discrepancy, scientists proposed the existence of an unseen, intangible substance, dark matter, that fills cosmic voids and holds galaxies together. The Big Bang theory suggests that the universe began as a singularity, a point of infinite density and temperature, about 13.8 billion years ago. This moment of cosmic inception marked the birth of space and time itself from what might be considered nothing in conventional terms. But how does this theory, describing the explosive birth of our universe, relate to the concept of nothing? To understand this, we must grasp the nature of the singularity at the Big Bang's moment. The singularity represents a state where the laws of physics break down, a point of infinite density and zero volume, defying our usual understanding of matter and space. In this sense, the singularity can be seen as a manifestation of nothingness, a point where the universe lacked its familiar structure and dimensions. However, this apparent nothingness was filled with potential. As the universe expanded from this singularity, it underwent rapid inflation, causing space to stretch exponentially in an instant. The universe transformed from a state of cosmic nothingness into a cauldron of energy, particles, and fundamental forces that shape our reality. During the initial moments of the Big Bang, the universe was extremely hot and dense, resembling a primordial soup of particles and radiation. In a fraction of a second, it underwent a series of transformations, including nucleosynthesis, where the first atomic nuclei formed. This cosmic evolution led to the emergence of stars, galaxies, and the intricate structure of the cosmos we observe today. How do we know the Big Bang happened? There is a lot of evidence supporting the Big Bang theory. One key piece is the cosmic microwave background radiation, which is like the afterglow from the early universe. This radiation gives us a picture of the universe just 380,000 years after the Big Bang, before which the universe was too hot and dense to take pictures of. Arno Penzias and Robert Wilson discovered this radiation by accident in 1965. The CMB's uniformity and slight fluctuations support the idea of cosmic inflation and rapid expansion of the universe. Another piece of evidence is the redshift of galaxies, meaning galaxies are moving away from us, showing the universe is expanding. Edwin Hubble first observed this in the 1920s. The farther away a galaxy is, the faster it seems to be moving away from us, supporting the idea that the universe was once much smaller, hotter, and denser. However, the Big Bang theory raises some big questions. For example, it doesn't explain what happened before the Big Bang, or what lies beyond the part of the universe we can see. It also introduces the idea of cosmic inflation, a rapid expansion that happened right after the Big Bang. Before the discovery of the cosmic microwave background radiation, there was a popular idea called the steady-state theory. This theory suggested that the universe has no beginning or end, but stays the same overall, even though it's expanding, by constantly creating new matter. This theory was popular in the 1940s, but lost support when scientists discovered the CMB radiation in 1965, strongly supporting the Big Bang theory. Additionally, there are theories like the cyclic model, which suggests the universe undergoes endless cycles of expansion and shrinking. After the Big Bang, the universe expanded and cooled. In the beginning, it was a hot, dense soup of particles. As it expanded, it cooled down, allowing particles to come together and form the first atoms. These atoms then formed the first stars and galaxies. The universe's expansion continues today, with galaxies moving away from us in all directions. Going even further back, the first long-lived particles were protons and neutrons, which make up the atomic nucleus. These appeared around 1/10,000th of a second after the Big Bang. Before that, there was no material as we know it. But physics allows us to trace the timeline even further back to processes that happened before any stable matter existed. To understand how the universe could begin from nothing, we need to explore the strange world of quantum mechanics. In quantum physics, nothing isn't the absence of anything, but rather a state of vacuum energy, where particles constantly pop in and out of existence. This phenomenon is known as quantum fluctuations. Quantum fluctuations happen in what is called the quantum vacuum, a state with the lowest possible energy where particles can momentarily appear and then vanish. According to quantum mechanics, these fluctuations can lead to the creation of a universe. So in this context, nothing is an energetic state that can give rise to matter and energy. A key concept here is Heisenberg's uncertainty principle, which states that certain pairs of physical properties, like position and momentum, cannot both be known precisely at the same time. This principle allows particles to temporarily pop into existence from the vacuum, as long as they disappear quickly enough to comply with the law of conservation of energy. Quantum fluctuations cause particles to appear and disappear shortly after. This might sound strange, but such particles have been observed in many experiments. The vacuum of space is filled with particles constantly being created and destroyed, seemingly out of nothing. This suggests that the quantum vacuum is actually something rather than nothing. Where did space-time itself come from? To answer this, we need to go back to the very beginning, into the Planck epoch. This period was so early in the universe's history that our best theories of physics no longer work. It happened only a tiny fraction of a second after the Big Bang. During this time, space and time themselves were affected by quantum fluctuations. Usually, physicists use quantum mechanics for tiny particles and general relativity for large cosmic scales. But to understand the Planck epoch, we need a complete theory of quantum gravity that combines the two. We don't have a perfect theory of quantum gravity yet, but there are ideas like string theory and loop quantum gravity. These theories suggest that ordinary space and time come from deeper, microscopic processes. What we experience as space and time is the result of quantum processes, which are hard for us to understand because we are used to the large-scale world. Quantum fluctuations happen constantly, even in what we consider empty space. According to the Heisenberg uncertainty principle, pairs of particles and antiparticles can emerge from the vacuum, exist for a short moment, and then destroy each other. This phenomenon is known as quantum foam. But quantum fluctuations alone don't explain the universe's vast scale and complexity. There is dark energy, a mysterious force that fills all of space and accelerates the expansion of the universe. While we don't fully understand dark energy, it's believed to play a crucial role in the creation and evolution of the cosmos. So how did we get from quantum fluctuations and dark energy to the vast, structured universe we see today? The answer lies in inflation, a rapid expansion that occurred fractions of a second after the Big Bang. During this brief period, the universe expanded exponentially, setting the stage for the formation of galaxies, stars, and planets. In the Planck epoch, our usual understanding of space, time, and cause and effect breaks down. Despite this, all candidate theories of quantum gravity describe something physical happening in the Planck epoch, some quantum precursor to ordinary space and time. But where did that come from? Even if causality doesn't work in the usual way, it might still be possible to explain parts of the Planck epoch universe in terms of other parts. Unfortunately, our best physics can't provide clear answers yet. Until we develop a theory of everything, we won't be able to give a definitive answer. The most we can say with confidence is that physics has not found any confirmed instances of something arising from nothing. In this context, the concept of nothingness takes on a dynamic and evolving character. It is not a stagnant void, but a canvas upon which the universe paints its story, a story that began with the explosive birth of the cosmos. The question of whether the vacuum of space truly constitutes emptiness, devoid of particles or fields, is a cornerstone of advanced cosmology. At first glance, we might envision the vacuum of space as an empty void, a vast expanse devoid of matter or energy. Yet, as we delve into the profound world of quantum mechanics, we encounter a remarkable revelation. The vacuum is not as vacant as our classical intuition suggests. Quantum mechanics, the framework of creating particles to the smallest scales, reveals extraordinary activity within the supposed emptiness of space. Here, the vacuum is far from silent, teeming with quantum fluctuations. These fluctuations are like subtle ripples on a tranquil pond, manifesting at the subatomic level. Fluctuations, particles and their antiparticles engage in a fleeting dance of existence, spontaneously emerging from the vacuum, annihilating each other in a brief cosmic ballet. These transitory events defy our classical understanding of emptiness, revealing a dynamic and ever-changing tapestry within the vacuum. Furthermore, the vacuum of space is not merely a passive backdrop, but an integral part of the cosmos. It hosts fields that govern the universe's fundamental forces, such as the electromagnetic field. These fields extend throughout space, even in regions perceived as empty. In advanced cosmology, it becomes evident that the vacuum of space is far from a true void. It is a dynamic arena where the boundary between nothing and something blurs, alive with the quantum fluctuations of particles and fields, challenging our preconceived notions of emptiness. Moreover, this concept has practical implications. Scientists harness the energy within these quantum fluctuations through a phenomenon known as the Casimir effect. When two parallel conducting plates are placed close together in a vacuum, they experience a minuscule but measurable attraction due to the suppression of certain vacuum fluctuations between them. This effect, though subtle, demonstrates the tangible consequences of nothingness within the vacuum. If something came from nothing, then what existed before nothing? Philosophically, nothing can be even more abstract. Some philosophers argue that true nothingness is an absolute void without any properties or existence. Others suggest that even in a state of nothingness, there must be some potential or possibility that allows something to emerge. None of the evidence from the cosmic microwave background radiation or quantum fluctuations tells us what was there before the Big Bang. One of the most mysterious questions in cosmology is what existed before the Big Bang and what created the singularity that led to it. The Big Bang theory tells us that the universe started from an incredibly dense and hot point called a singularity. Think of a singularity as a point where everything we know about space and time breaks down, including the laws of physics. If our usual laws of physics don't apply here, then what are the rules? To understand this, let's start with Albert Einstein's ideas. His theory of relativity changed how we see the universe by linking mass and time. According to his theory, time is not fixed, but changes based on the gravitational fields of objects with significant mass. He showed that massive objects, like Earth, can slow down time. Now, if mass slows down time, imagine what the singularity does, containing all the mass of the universe. It would stop time completely. So according to Einstein, the idea of before the Big Bang doesn't really make sense, because time itself didn't exist. The cosmic microwave background radiation is a key piece of evidence. It comes from a time about 380,000 years after the Big Bang, when the universe was cooling down and forming hydrogen atoms. Before this 380,000-year mark, the universe went through several phases, starting from the Planck epoch to the Grand Unification, inflationary, electroweak, quark, and hadron epochs. Each phase saw different particles and forces evolving into what we know today. When we talk about the universe at such a small scale, quantum mechanics takes over from classical physics. This led scientists like Stephen Hawking to think about how quantum theory could apply to the whole universe. This is where inflationary quantum cosmology comes in. Unlike classical theories that describe the singularity as a point with zero volume, quantum cosmology suggests there's an element of uncertainty. This means we can't pinpoint the exact moment the universe was created, and particles can pop in and out of existence from what we call a vacuum. In physics, a vacuum is not a state of absolute emptiness, but rather a state without particles. According to Heisenberg's uncertainty principle, there's always some level of fluctuation, so a perfect vacuum with zero field values is impossible. This might sound strange, but Einstein's famous equation, E equals mc squared, helps explain it. The positive energy in stars and galaxies must be balanced by an equal amount of negative energy, like gravity. If the universe's total energy is zero, then it's possible for it to come from nothing. The idea that hundreds of billions of galaxies could come from nothing sounds unbelievable. However, Einstein's famous equation, E equals mc squared, gives us some clues. According to this equation, all the positive energy in stars, galaxies, and other celestial bodies must be balanced by an equal amount of negative energy, which appears as gravity. In a closed universe, or one that will eventually collapse back onto itself, these positive and negative energies would perfectly cancel each other out, resulting in a net energy of zero for the universe as a whole. Stephen Hawking asked how a universe with zero total energy could come from nothing. He suggested that gravity's negative energy could balance out the positive energy needed to create matter. This makes empty space stable. Physicist Alexander Vilenkin took this idea further, showing that a small energy-filled vacuum could spontaneously appear from nothing and expand into the universe we see today. This means our universe could have started from a state of nothing where time didn't exist. Another intriguing possibility is the multiverse hypothesis. which suggests that our universe is just one of many universes that exist simultaneously. In this idea, the Big Bang that created our universe might be just one of countless such events occurring within a larger multiverse. In the multiverse scenario, new universes could be constantly created, each with its own set of physical laws and constants. These universes could be born from different processes, such as quantum fluctuations or collisions between higher dimensional membranes in string theory. This implies that our universe's beginning was just one event in an endless cycle of creation and destruction. Some theories in physics propose the existence of higher dimensions beyond the familiar three spatial dimensions and one time dimension. These higher dimensions could play a crucial role in the origin of the universe. String theory, for example, suggests that the fundamental building blocks of the universe are one-dimensional strings that vibrate in multiple dimensions. In this framework, our universe could be a three-dimensional brain floating in a higher dimensional space. Collisions or interactions between these brains could trigger events like the Big Bang, creating new universes. So what was there before the Big Bang? The theories we've explored suggest that time itself started with the Big Bang, making before a tricky concept. From singularities to quantum fluctuations, these ideas show just how incredible and mysterious our universe really is. The Big Bang theory explains how the universe expanded from a superhot and dense state, but it doesn't tell us what happened before that moment. According to the theory, time, space, matter, and energy all started with the Big Bang. However, some scientists have ideas about what might have been before the Big Bang. One interesting idea is the Big Bounce. This theory suggests that the universe goes through cycles of expanding and contracting. So the Big Bang we know might have been just one of many bounces, with the universe constantly being reborn. Another fascinating idea is the concept of a multiverse. This theory proposes that our universe is just one of many universes, each with its own set of physical laws. In this model, what existed before our Big Bang could have been another universe entirely. These ideas push the limits of our current understanding and venture into the speculative. They rely on advanced concepts in quantum physics and the still theoretical realm of quantum gravity. Scientists are trying to connect the dots between quantum mechanics and general relativity to better understand these possibilities. After the Big Bang, the universe kept expanding and cooling. At first, it was just a soup of tiny particles. As it cooled, these particles came together to form the first atoms, mainly hydrogen and helium. While these theories offer exciting glimpses into what might have been before the Big Bang, they remain largely theoretical, highlighting the deep mystery of our universe's origins. By looking back in time, we can explore the origins of each cosmic structure. Each discovery leads to another question. Where did this come from, and how did it form? These questions continue until we reach a point where the only honest answer is, we don't know, at least not yet. With what we do understand, we then face the intriguing questions. How did all of this come to be? The life we see today is made possible by complex molecules, which originally evolved from the simple atoms listed in the periodic table. These atoms are the fundamental components of all the ordinary matter in our universe. These atoms weren't just there from the universe's beginning, they formed through numerous cycles of stars being born, living, and dying. Each cycle of stellar life contributed to the nuclear reactions that produced these atoms, which were then recycled into newer generations of stars. Without this ongoing process, the creation of planets and the complex chemistry needed for life would not have been possible. To understand how the stars and galaxies we see today came to be, a few key pieces need to fit into place. First, gravity plays a huge role. It pulls together smaller groups of stars and galaxies to form the large galaxies we observe, kickstarting new rounds of star formation. For gravity to do its job, there must be enough mass already clumped together. This is where dark matter comes in. Early in the universe's history, dark matter formed halos that helped keep the newly formed stars from scattering their material back out into space. Besides, the right mix of matter like atoms, dark matter, and radiation is crucial. This mix not only produced the cosmic microwave background, a kind of afterglow from the Big Bang, but also created the light elements during that hot, dense state of the early universe. The growth of galaxies and star clusters depended on initial small differences in density. often called seed fluctuations, which needed to grow under gravity's influence. Finally, there must be processes that initially created these density variations, dark matter, and the first batches of ordinary matter. To grasp how our universe came to be from the chaos of the Big Bang, we need to consider some critical conditions right from the start. For one, the laws of physics, the fabric of space-time, and the essence of matter-energy weren't just there, they had to emerge somehow. The birth of the universe is a fascinating tale that begins with the concept of cosmic nothingness. Before the Big Bang, what we perceive as nothing wasn't empty space but rather a quantum vacuum where particles and antiparticles continuously appeared and disappeared. According to quantum mechanics, these fluctuations could have given rise to the Big Bang, a massive event that marked the beginning of time and space as we know it. This theory suggests that the universe emerged from an incredibly dense and hot singularity, expanding rapidly in an event known as inflation. During this brief period, the universe grew exponentially, smoothing out any irregularities and setting the stage for the formation of matter. As the universe expanded and cooled, it reached a critical phase called recombination. This period occurred around 380,000 years after the Big Bang, when electrons and protons combined to form neutral hydrogen atoms. This process had a profound impact, allowing photons to travel freely through space for the first time. These photons are now observed as the cosmic microwave background radiation, which provides a snapshot of the universe in its infancy. The CMB is a faint glow that permeates the entire cosmos, offering critical insights into the early universe's conditions. It marks the first light of the universe, illuminating the path from a hot, opaque plasma to a transparent, expanding cosmos. Following recombination, the universe entered a period known as the Dark Ages, a time before stars and galaxies had formed. However, the seeds for cosmic structures had already been sown. Tiny fluctuations in the density of matter left over from the inflationary period began to grow under the influence of gravity. Over millions of years, these fluctuations attracted more matter, eventually leading to the formation of the first stars and galaxies. These early stars ignited through nuclear fusion, producing light and heat and beginning the process of reionization, which made the universe transparent once again. The formation of stars and galaxies marked the end of the cosmic dark ages and the beginning of the structured universe we see today. The formation of galaxies and their subsequent evolution from the initial state of nothingness is a remarkable process. As matter clumped together under gravity, galaxies began to form, often in clusters and superclusters. Dark matter, an invisible and mysterious substance, played a crucial role in this process. It provided the gravitational scaffolding necessary for galaxies to form and hold together. Observations of the large-scale structure of the universe reveal a vast cosmic web, with galaxies and clusters connected by filaments of dark matter. This intricate structure emerged from the initial quantum fluctuations, illustrating how the universe evolved from a seemingly empty vacuum to a richly textured cosmos filled with diverse galactic formations. The universe we observe today can be thought of as a grand cosmic stage, set into motion by the Big Bang and shaped by the interplay of dark matter, gravity, and the fundamental forces of nature. This stage is adorned with countless galaxies, each containing billions of stars, planets, and other celestial objects. The cosmic microwave background radiation provides the backdrop, reminding us of the universe's humble beginnings. The ongoing expansion of the universe continues to shape this stage, driving galaxies apart and influencing the evolution of cosmic structures. The concept of nothingness, once a profound mystery, is now understood to be a fertile ground for the birth and evolution of the universe. To truly answer the question of how something could arise from nothing, we first need to understand several interpretations of nothing. This is the state where the essential building blocks for everything we see are absent. Imagine a universe with no galaxies, stars, planets, or even humans. Everything we know and interact with is made up of tiny subatomic particles. These particles are the building blocks that shape our universe. If we start with a universe full of matter, we can understand how it grows, cools down, and is influenced by gravity to become the universe we see today. Stars go through life cycles, creating heavier elements that lead to the birth of new stars, planets, organic compounds, and eventually life. But here are some big scientific questions. How did we end up with a universe dominated by matter, and not one with equal amounts of matter and antimatter? This is one of the biggest mysteries in physics. The universe is made almost entirely of matter, with hardly any antimatter. Every star, planet, and galaxy we've observed is made of matter. So how did we get this surplus of matter? This puzzle is known as baryogenesis, the process of creating an excess of baryons over antibaryons in the early universe. Scientists have many theories, but we still don't have a definitive answer. We don't know why there's more matter than antimatter instead of an equal balance. Our second interpretation of nothing is the emptiness of vast space. Maybe you think of nothing as truly having no things at all. If that's the case, then the first explanation of nothing with missing building blocks doesn't quite fit because it still involves something. To really understand this concept of nothingness, let's imagine getting rid of every basic element of matter. That means removing every single particle and every bit of energy. If we could manage to remove all of these, what would remain? Just the vast expanse of empty space. No particles, no matter, no radiation at all. This is what some scientists see as the true scientific meaning of nothingness. Space-time itself, guided by the principles of general relativity, still exists. The speed of light and gravitational constant still retain their values. And most importantly, there's something called zero-point energy. Even in the emptiest space, there's still a tiny amount of energy. Today, we see this as dark energy, which is driving the expansion of the universe. But even in this extremely empty scenario, some fundamental aspects still remain. The laws of physics are still there. Quantum fields, like the electromagnetic field, the gravitational field, the Higgs field, and fields related to nuclear forces still exist. So even without any matter or radiation, this version of nothing still gives rise to an intriguing universe. It's fascinating to think that even in the absence of everything we see, the universe can still be a dynamic and captivating place. The third interpretation of nothing for scientists is the idea of nothingness as the lowest energy state possible. Right now, our universe has something called zero-point energy. This is a tiny amount of energy that exists everywhere in space. We don't know if this zero-point energy is the absolute lowest energy possible, or if there's an even lower energy state we haven't discovered yet. There's a chance we might be in a false vacuum state, with the true vacuum or the absolute lowest energy state either near zero or perhaps even reaching or surpassing it. If the universe changes from this false vacuum to a true vacuum, it could trigger a catastrophic event called vacuum decay. This would drastically change the universe. Photons, which are particles of light, would get mass, the electromagnetic force would be confined to short distances, and most of the sunlight from the sun wouldn't reach Earth. Thinking of nothingness as the ultimate lowest energy state means imagining a situation where all matter, energy, radiation, and any distortions in space-time are removed. What remains is a state of perfect emptiness, but with the laws of physics still in place. This ultimate low-energy state would make it impossible to create any work, energy, or particles from it. However, some might still see this as something because space, time, and the laws of physics would still exist. In this state, there would still be a backdrop for events to happen, but without any actors or actions. It would be like a play with no characters, storyline, or setting, just an empty stage. Imagine reaching the universe's true foundational state, whatever that might be. In this state, all matter, energy, and any distortions in space-time would be removed. What would be left is the ultimate material emptiness. This ultimate low-energy state would make it impossible to create any work, energy, or particles from it. However, some might still see this as something because space, time, and the laws of physics would still exist. So our third interpretation of nothing is the ultimate lowest energy state possible for the universe. Even in this state, the framework of space, time, and the laws of physics remain. It's another incredible mystery that keeps scientists exploring and searching for answers. This is the most extreme interpretation of nothing. It's the idea that true nothingness only happens when the entire universe and its governing laws are completely gone. This is a radical idea that goes beyond our usual understanding of reality. Imagine getting rid of everything, including space, time, and even the laws of physics. This kind of nothing is beyond what we can define with physics because it represents an absolute void, a total absence of everything. From a physics standpoint, this idea is challenging. How can something like space-time exist if there's no space or time? How can the laws of physics work if there's no framework for them? This kind of nothing is hard to comprehend and might not have any real-world meaning. Thinking about this ultimate nothingness brings up many questions without clear answers. For instance, how could space and time begin in a place where they don't exist? Is it possible to have something without space or something starting without time? Imagine an absolute nothingness, a complete void. From a physics perspective, it suggests a state beyond the limits of space and time, from which our universe and its laws might have originated. However, we're not sure if this idea is meaningful or just a product of our imagination. This concept raises many difficult questions. For instance, how can space and time begin in a place or moment where neither exists? Can we even imagine something existing outside the universe without space or starting without time? Where would the rules that govern particles and their interactions come from? This idea of nothingness, while it seems philosophically complete, might not have any real substance. It could just be a way for us to understand things that are beyond our reality. When scientists talk about nothing, they often assume everyone has the same idea of what nothing means. But that's not always the case. Different people and different contexts can change how we understand nothing. While theories about nothing are grounded in scientific principles and observations, the study of the cosmic microwave background radiation, the faint afterglow of the Big Bang, provides insights into the early universe's conditions. Detailed measurements of the CMB have helped our understanding of the universe's age, composition, and structure. Observations of the expansion of the universe, as described by Hubble's law, support the idea that the universe began from a hot, dense state. Additionally, the discovery of dark matter and dark energy, which make up most of the universe's mass-energy content, suggests that our understanding of the universe is still incomplete. The phrase "something from nothing" might mean creating something entirely new where there was truly nothing before. But not everyone agrees on what nothing really means. In the end, it's important to understand which version of nothing someone is talking about. In simple terms, nothingness refers to the absence of matter, energy, and even the space-time fabric. However, the reality is far more intricate. Quantum mechanics suggests that even in a perfect vacuum, particles and antiparticles constantly pop in and out of existence. This quantum fluctuation could be the key to understanding how our universe emerged from a state of nothingness. One essential player in this cosmic dance is dark matter, an elusive and mysterious form of matter that does not emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. Dark matter, despite its elusive nature, consists of about 27% of the universe, playing a crucial role in its formation and evolution. Dark matter acts as the cosmic scaffold upon which the universe is built. It is believed that dark matter provided the necessary gravitational pull to bring together ordinary matter and form galaxies, stars, and planets. Without dark matter, the universe would be a vastly different place, likely devoid of the complex structures we observe today. The initial conditions of the universe, characterized by quantum fluctuations, allowed for the uneven distribution of dark matter. These fluctuations grew over time, creating dense regions where galaxies could form. Thus, dark matter was the invisible framework that guided the formation of the universe from the chaos of the Big Bang. The role of dark matter extends beyond merely being a scaffold. It is integral to the stability and formation of cosmic structures. Observations of galaxies and galaxy clusters show that visible matter alone cannot account for the observed gravitational effects. Dark matter provides the additional mass needed to explain these phenomena. For instance, the rotational speeds of galaxies do not decrease with distance from the center as expected if only visible matter were present. This discrepancy is resolved by the presence of dark matter, which exerts a gravitational pull, holding galaxies together. In essence, dark matter acts as the glue that binds the universe's structures, allowing them to form and persist over billions of years. The influence of dark matter is not confined to the formation of galaxies and large-scale structures. It also affects the universe's overall behavior. Dark matter interacts with normal matter through gravity, influencing the distribution and movement of galaxies. This interaction helps scientists map the presence of dark matter by observing the gravitational lensing effect, where light from distant objects is bent by the gravitational pull of dark matter. These observations reveal the invisible parts of the universe, providing insights into its composition and evolution. The study of dark matter also opens doors to understanding other fundamental aspects of the cosmos, such as the nature of gravity and the potential existence of new particles and forces. One of the most compelling pieces of evidence for the Big Bang and the role of dark matter is the cosmic microwave background. The CMB is the afterglow of the Big Bang, a faint radiation that fills the universe and provides a snapshot of the infant universe just 380,000 years after its birth. This radiation carries information about the early universe's density fluctuations, which were the seeds for the formation of galaxies and clusters. The patterns observed in the CMB support the presence of dark matter, as they align with theoretical models that include dark matter's gravitational effects. The CMB is a crucial tool in cosmology, offering a glimpse into the universe's earliest moments and the fundamental forces at play. One of the most impactful ways to understand how the universe formed from nothing, we need to learn about the recombination era. This era, occurring approximately 380,000 years after the Big Bang, was when electrons and protons first combined to form neutral hydrogen atoms. Before recombination, the universe was a hot, dense plasma where photons couldn't travel freely due to constant interactions with charged particles. As the universe cooled, these particles combined, allowing photons to travel unimpeded. This transition marks the release of the cosmic microwave background radiation, providing us with a snapshot of the early universe. The CMB is a relic from the Big Bang, carrying imprints of the universe's initial conditions and offering invaluable insights into its origins. The cosmic microwave background is often referred to as the persistent echo of the Big Bang. This faint, uniform radiation fills the entire universe, acting as a cosmic backdrop. Its discovery in 1965 by Arno Penzias and Robert Wilson provided strong evidence for the Big Bang theory. The CMB is remarkably uniform, but it contains tiny fluctuations in temperature. These fluctuations, measured by missions like the Cosmic Background Explorer and the Wilkinson Microwave Anisotropy Probe, reveal information about the early universe's density variations. These variations were the seeds from which galaxies and large-scale structures eventually formed. The CMB, therefore, is not just an afterglow, but a critical component in understanding the universe's evolution from an initial state of nothingness. In the realm of quantum mechanics, even a perfect vacuum is teeming with temporary changes in energy levels, creating particles and antiparticles that pop in and out of existence. These fluctuations are minute and usually cancel each other out, but they played a crucial role in the early universe. The Big Bang itself can be viewed as a massive quantum fluctuation. According to some theories, such as those involving quantum cosmology, the universe could have spontaneously emerged from a state of absolute nothingness due to these fluctuations. This concept challenges our classical understanding of nothing, suggesting that even in the absence of matter and energy, the potential for creation exists. These quantum fluctuations didn't just initiate the universe, they also shaped its subsequent evolution. The initial tiny fluctuations in the early universe grew under the influence of gravity, leading to the formation of galaxies, stars, and planets. This dance of quantum fluctuations set the stage for the large-scale structures we observe today. The fluctuations left imprints in the cosmic microwave background, providing a detailed map of the universe's primordial density variations. Over billions of years, these variations are amplified, driven by dark matter's gravitational pull, culminating in the cosmic web of galaxies and clusters. This intricate interplay between quantum mechanics and cosmic evolution underscores the profound connection between the minute world of quantum particles and the vast expanse of the universe. Bringing these concepts together, we see a coherent narrative of the universe's formation from nothing. The era of recombination and the release of the cosmic microwave background provide a window into the early universe, revealing the fingerprints of quantum fluctuations. These fluctuations, arising from the seemingly empty void, acted as the seeds for all cosmic structures. The persistent echo of the Big Bang, captured in the CMB, serves as a testament to these early processes. Quantum mechanics, with its counterintuitive principles, offers a framework for understanding how the universe could emerge from a state of absolute nothingness, driven by the dance of quantum fluctuations. This interconnected story highlights the intricate tapestry of forces and phenomena that gave rise to the universe as we know it. The concept of quantum fluctuations plays a crucial role in understanding how the universe could have formed from nothing. These fluctuations are temporary changes in energy that occur spontaneously in the vacuum of space, even in the absence of matter. In the early universe, these fluctuations were amplified by inflation, a rapid expansion that occurred fractions of a second after the Big Bang. This amplification led to the creation of tiny, uneven distributions of matter and energy, which eventually grew into the large-scale structures we observe today, such as galaxies and clusters. The practical implications of this are profound. It means that the universe's initial conditions, seeded by quantum fluctuations, set the stage for everything that followed. Without these fluctuations, the universe might have remained a uniform, featureless expanse. Cosmic voids are vast, empty spaces between clusters of galaxies, comprising about 80% of the universe's volume. These voids are not truly empty, but they contain far less matter than other regions of space. In the context of the universe's formation, cosmic voids offer a unique perspective on the concept of nothingness. They are regions where the density of matter is exceedingly low, yet they play a significant role in the universe's overall structure. The existence of cosmic voids supports the idea that the universe is a complex and dynamic entity, where even the seemingly empty regions have a part to play in its grand design. These voids help us understand the distribution of matter and the gravitational forces at work on a cosmic scale. Despite their name, cosmic voids are not completely empty. They contain dark matter, sparse gas, and sometimes even galaxies. The presence of dark matter within these voids is particularly intriguing because it does not emit, absorb, or reflect light, making it invisible to traditional detection methods. However, its gravitational effects can be observed. The subtle presence of dark matter in cosmic voids contributes to our understanding of the universe's structure and evolution. It acts as a scaffold, influencing the formation and distribution of galaxies. This subtle yet significant presence underscores the idea that even in the vast nothingness of cosmic voids, there are essential components that shape the cosmos. The universe's formation from nothing is also evidenced by the persistent traces of matter left behind. These traces can be seen in the cosmic microwave background, the afterglow of the Big Bang. The CMB provides a snapshot of the universe when it was just 380,000 years old, revealing slight fluctuations in temperature that correspond to regions of varying density. These density variations are the fingerprints of the universe's earliest moments, imprinted by quantum fluctuations. As the universe expanded and cooled, these traces of matter coalesced to form stars, galaxies, and other structures. The CMB is a vital tool in cosmology, offering a glimpse into the universe's infancy and the processes that led to its current state. The expansion of the universe is a fundamental aspect of its evolution, directly linked to the concept of nothingness. According to the Big Bang theory, the universe began as an infinitely small, hot, and dense point, which then expanded rapidly. This expansion is still ongoing, driven by a mysterious force known as dark energy. The idea that the universe is expanding into nothing challenges our conventional understanding of space and time. It suggests that the universe creates new space as it expands, rather than expanding into a pre-existing void. This concept is difficult to grasp, but it is supported by observations of distant galaxies moving away from us, indicating that the fabric of space-time itself is stretching. The expansion of the universe from a seemingly nothingness state underscores the dynamic and ever-changing nature of the cosmos. Bringing these subtopics together, we can see a coherent narrative of the universe's formation from nothing. Quantum fluctuations provided the initial seeds of matter and energy, which were amplified by cosmic inflation and left persistent traces in the form of the cosmic microwave background. Cosmic voids, though seemingly empty, contain subtle presences of dark matter and sparse gases that contribute to the universe's structure. The ongoing expansion of the universe into nothing highlights the dynamic nature of spacetime and the continuous creation of new space. These interconnected concepts illustrate the profound and intricate processes that transformed a state of apparent nothingness into the rich and diverse universe we observe today. Nothing has been thought of as a complete void, an absence of matter, energy, and space. However, modern physics complicates this idea. According to quantum mechanics, even what we consider nothing is actually a quantum vacuum filled with fluctuating energy fields and virtual particles. This quantum vacuum is not truly empty, but a state where particles can spontaneously appear and disappear. In cosmological terms, nothing might be better understood as a state of extremely low energy, where the universe's potential could give rise to the matter and energy we observe today. This nuanced definition of nothingness is crucial for understanding how the universe could emerge from what was initially perceived as a void. Another possible idea of how our universe was born is the Big Crunch, that describes the potential ultimate fate of the universe, opposing the currently observed expansion. According to this model, if the density of the universe were high enough, gravitational forces could eventually slow down and reverse the expansion, leading to a contraction. In this scenario, the universe would collapse back into a hot, dense state, potentially similar to the conditions that existed at the Big Bang. The Big Crunch represents a return to a state of extreme density and temperature, effectively closing the cosmic cycle. While current observations suggest that the universe's expansion is accelerating, the concept of the Big Crunch remains a critical part of understanding the possible end states of the universe and its dynamic evolution from a state of near-nothingness. The Big Freeze, also known as the heat death, is another theoretical outcome for the universe's future. In this scenario, the universe continues to expand indefinitely, leading to a gradual decline in temperature and energy density. As galaxies move further apart and stars burn out, the universe would approach a state of maximum entropy, where energy is uniformly distributed and no thermodynamic work can be performed. This state represents a cosmic equilibrium where matter and energy are evenly spread, and no significant structures or processes occur. The Big Freeze illustrates the long-term implications of an expanding universe and provides insight into the eventual fate of cosmic structures. It contrasts with the Big Crunch by emphasizing a universe that grows increasingly cold and dark, a final stage after the universe's emergence from nothingness. Another way of thinking about the idea of nothingness is that maximum entropy and ultimate disorder. These are the concepts related to the thermodynamic fate of the universe. Entropy is a measure of disorder or randomness in a system, and the concept of maximum entropy describes a state of complete thermodynamic equilibrium. As the universe expands and evolves, entropy tends to increase, leading to greater disorder. In the context of the Big Freeze or heat death, the universe would eventually reach a state of maximum entropy, where energy is evenly distributed and no further work or organization is possible. This state represents the ultimate end of cosmic evolution, where the universe has transitioned from a dynamic, evolving state to one of uniformity and stagnation. Understanding maximum entropy helps us grasp the eventual fate of the universe and the long-term consequences of its expansion from a state of near-nothingness. The Big Rip is a speculative scenario describing a potential end state of the universe characterized by the accelerated expansion of space. In this model, dark energy, which is driving the universe's accelerated expansion, would increase in strength over time, causing the expansion rate to grow exponentially. Eventually, this would lead to the tearing apart of galaxies, stars, planets, and even atomic structures. The Big Rip represents an extreme outcome where the fabric of the universe is progressively torn asunder, culminating in a state of complete disintegration. This scenario contrasts with the Big Freeze and Big Crunch by emphasizing the disruptive effects of an ever-accelerating expansion. Understanding the Big Rip provides insights into the potential extremes of cosmic evolution and the dynamic forces driving the universe's future. Entropy, a measure of disorder or randomness in a system, is a crucial concept in understanding the universe's formation from nothing. In thermodynamics, entropy tends to increase over time, leading systems from states of lower entropy to higher entropy. The universe's initial state can be seen as having extremely low entropy, highly ordered and compact. As the universe expanded following the Big Bang, entropy increased, leading to the formation of galaxies, stars, and other complex structures. This process illustrates how the universe transitioned from a state of near nothingness, with minimal entropy, to its current, highly organized state. The concept of nothing here is a state with very low entropy, where quantum fluctuations could give rise to matter and energy, kickstarting the universe's evolution. A mysterious force driving the accelerated expansion of the universe is known as dark energy. The nature of dark energy remains one of the biggest mysteries in cosmology. Some alternative theories suggest that the universe could be part of a multiverse, where multiple universes exist with different physical laws and constants. In this framework, our universe's emergence from nothing might be just one of many such events occurring within a larger multiverse. These theories challenge the traditional concept of nothingness by suggesting that our universe's birth could be part of a more extensive, interconnected cosmic system influenced by forces like dark energy. The concept of time is integral to understanding the notion of nothing and the universe's formation. In classical physics, time is a linear progression from past to future, a constant backdrop against which events occur. However, in the context of the universe's beginning, time itself is thought to have originated with the Big Bang. Before this event, conventional concepts of time and space did not exist, meaning the universe emerged from a state where time as we understand it was absent. This idea challenges our perception of nothingness, suggesting it is not just the absence of matter and energy, but also the absence of time. The emergence of the universe from this timeless state marks the beginning of temporal and spatial dimensions. Modern physics has significantly evolved our understanding of time. In general relativity, time is not separate from space, but is part of a four-dimensional space-time fabric. The presence of mass and energy warps this fabric, affecting the passage of time, a phenomenon known as time dilation. This means time can pass at different rates depending on the gravitational field and relative motion. Quantum mechanics adds another layer of complexity, introducing the concept of quantum fluctuations, where particles and energy appear and disappear spontaneously, affecting time at microscopic scales. These theories suggest that time is not a fixed, absolute entity, but a dynamic, relative aspect of the universe. This modern understanding of time provides a framework for comprehending how the universe could emerge from a state of near nothingness, where time itself is fluid and interconnected with the fabric of space. While diving deep into the concept of nothing, time dilation also comes forward. Time dilation is a phenomenon predicted by Einstein's theory of general relativity, which describes how time can be stretched or compressed, depending on the strength of a gravitational field. In regions of strong gravitational fields, such as near a black hole, time passes more slowly compared to areas with weaker gravitational fields. This effect is known as gravitational time dilation. For instance, if you were to observe a clock near a massive object, you would see it tick slower compared to a clock far away from that object. This concept is crucial for understanding the nature of time in the universe, particularly in the context of extreme environments like the early universe or the vicinity of massive cosmic structures. The relativity of time is a core principle of both special and general relativity. In special relativity, time is relative to the observer's state of motion. For someone traveling at speeds close to the speed of light, time would pass more slowly compared to someone at rest. This effect, known as time dilation, means that time is not absolute, but depends on the observer's velocity. General relativity extends this concept by showing that time is also affected by gravity. These relativistic effects mean that time can vary across different regions of the universe, influenced by both the observer's movement and the presence of massive objects. Gravitational time dilation specifically refers to the slowing down of time in strong gravitational fields. This phenomenon has been confirmed through various experiments and observations. For example, precise measurements of time using atomic clocks on Earth's surface and in orbit show slight differences due to Earth's gravitational field. Gravitational time dilation is particularly significant in extreme environments such as near black holes or neutron stars. Understanding this concept helps explain how time can behave differently across the universe and provides insights into the early moments of the universe when gravitational forces were extraordinarily strong. Cosmic expansion is the phenomenon where the universe has been growing since the Big Bang, with galaxies moving away from each other over time. This expansion affects our perception of time and space. As the universe expands, it stretches the fabric of space-time, influencing how time is experienced across different regions. The expansion rate, driven by dark energy, leads to a dynamic and evolving universe. This continual expansion means that the universe is constantly changing, and time, as we experience it, is intertwined with the expanding space-time fabric. Understanding cosmic expansion is essential for comprehending the large-scale structure of the universe and its evolution from a state of near-nothingness. Quantum mechanics introduces a different perspective on time compared to classical physics. In the quantum realm, particles exist in states of superposition, where they can be in multiple states simultaneously. This inherent uncertainty affects our understanding of time at microscopic scales. Unlike the deterministic view of time in classical physics, quantum mechanics suggests that time is probabilistic and influenced by quantum fluctuations. These fluctuations played a crucial role in the early universe, potentially giving rise to the Big Bang from a quantum vacuum. Quantum mechanics challenges our classical notions of time and introduces new complexities in understanding how the universe emerged from nothingness. Wormholes, theoretical passages through space-time, are solutions to the equations of general relativity proposed by Einstein and physicist Nathan Rosen, hence sometimes called Einstein-Rosen bridges. These hypothetical structures could, in principle, connect distant points in space-time, allowing for instantaneous travel across vast distances or even different times. If wormholes exist, they might contain closed time-like curves, which are paths in space-time that loop back on themselves, theoretically allowing for time travel. It suggests that one could travel back to an earlier point in time, raising fascinating possibilities and significant challenges for our understanding of causality and the fabric of reality. The concept of time travel, especially through wormholes, introduces several paradoxes that challenge our understanding of logic and causality. One well-known example is the grandfather paradox, where a time traveler goes back in time and prevents their grandfather from meeting their grandmother, thereby preventing the traveler's own birth. This creates a logical inconsistency. If the traveler was never born, how could they travel back in time to prevent their birth? Another paradox is the bootstrap paradox, where an object or piece of information sent back in time becomes the very thing that triggers its own existence in the future, creating a loop with no clear origin. These paradoxes highlight the potential contradictions and complexities involved in time travel, questioning the consistency of the timeline and the nature of free will. Resolving these paradoxes requires new theoretical frameworks or interpretations of physics that can accommodate such scenarios without violating fundamental principles. Telescopes and observatories are fundamental tools for exploring the universe and understanding its origins. From the early days of astronomy with optical telescopes to the development of space-based observatories, these instruments have revolutionized our ability to observe celestial phenomena. Optical telescopes, such as the Hubble Space Telescope, have provided detailed images of distant galaxies and cosmic structures, revealing the universe's complexity and evolution. More recently, advancements in technology have led to the creation of specialized observatories, like the Chandra X-ray Observatory and the Very Large Telescope, which observe different wavelengths of light and offer insights into high-energy processes and cosmic radio signals. These observations are crucial for testing theories about the universe's formation and providing empirical evidence to support or refute scientific models. Robotic missions and space probes have expanded our knowledge of the universe beyond what can be achieved with telescopes alone. Missions like the Voyager probes, which were launched in the 1970s, have traveled far beyond our solar system, providing valuable data about the outer reaches of the heliosphere and interstellar space. More recent missions, such as the New Horizons probe to Pluto and the James Webb Space Telescope, have continued to push the boundaries of our exploration. Space probes gather detailed information about the planets, moons, and other celestial bodies, helping us understand their compositions, atmospheres, and potential for supporting life. This data is essential for piecing together the broader picture of the universe's evolution from a state of nothingness. Supercomputing and simulations play a critical role in modern cosmology, allowing scientists to model complex processes and phenomena that are difficult or impossible to observe directly. By using powerful computers, researchers can simulate the evolution of the universe from the Big Bang to the present day, incorporating various physical laws and cosmic parameters. These simulations help in understanding how structures like galaxies and black holes formed and evolved over time. They also enable scientists to test different theories about the universe's origins and predict future observations. The results from these simulations provide a virtual laboratory for exploring scenarios that are beyond the reach of current observational technology. The James Webb Space Telescope represents a significant advancement in our ability to observe the universe. Launched in December 2021, JWST is designed to observe in the infrared spectrum, allowing it to see through dust clouds and capture light from the earliest galaxies formed after the Big Bang. Its advanced instrumentation and large mirror enable it to gather unprecedented detail about distant cosmic objects. JWST's observations are expected to provide new insights into the formation of stars, galaxies, and planetary systems, further illuminating the processes that shape the universe from its earliest moments. This telescope is a key tool in revolutionizing our understanding of cosmic history and the origins of the universe. The second Lagrange point is a crucial location for space observatories like the JWST. Positioned about 1.5 million kilometers from Earth, L2 provides a stable environment with minimal interference from Earth's heat and light. This location allows telescopes to have an uninterrupted view of space, essential for observing distant and faint cosmic objects. The journey to L2 involves precise calculations and maneuvers to ensure that the spacecraft reaches and remains in this stable orbit. By positioning observatories at L2, scientists can maximize their ability to collect data and perform observations, contributing to our understanding of the universe's formation and evolution. The James Webb Space Telescope represents a significant leap forward in our ability to observe and understand the universe. Launched in December 2021, the JWST boasts unprecedented capabilities that are revolutionizing our exploration of the cosmos. Equipped with a large, segmented primary mirror and cutting-edge instruments, the JWST can observe the universe in infrared wavelengths, which allows it to see through cosmic dust clouds and capture images of distant and faint objects that were previously obscured. Its advanced capabilities include high-resolution imaging and spectroscopy, enabling scientists to analyze the composition and atmospheres of distant galaxies, stars, and exoplanets with remarkable detail. The JWST's ability to peer into the early universe provides crucial insights into the formation of the first galaxies, stars, and planetary systems, offering a deeper understanding of the universe's origins from a state of near nothingness. One of the most exciting aspects of the JWST is its potential for exoplanetary exploration. The telescope's instruments are specifically designed to study the atmospheres of exoplanets, which are planets located outside our solar system. By analyzing the light that passes through an exoplanet's atmosphere during transits when the planet moves in front of its host star, the JWST can detect the chemical composition, temperature, and weather patterns of these distant worlds. This capability allows scientists to search for signs of habitability and potentially even life. The JWST's observations of exoplanets will be instrumental in understanding the diversity of planetary systems and their formation processes, shedding light on how planets and their atmospheres evolve from the primordial conditions of the early universe. The JWST is poised to make a range of groundbreaking discoveries that will significantly enhance our understanding of the universe. One of its key goals is to observe the formation of the first galaxies, stars, and black holes, providing insights into the conditions and processes that occurred shortly after the Big Bang. By examining the early universe, the JWST can help us understand how the first cosmic structures emerged from a state of near-nothingness. Additionally, the telescope's ability to study distant exoplanets and their atmospheres may lead to the discovery of potentially habitable worlds and even signs of extraterrestrial life. The JWST's advanced observational capabilities will likely yield a wealth of new information about the cosmos, reshaping our understanding of its formation and evolution. The JWST represents a pinnacle of technological advancement in space observatories. Its design incorporates several cutting-edge technologies, including a large segmented mirror that provides exceptional clarity and resolution, and advanced instruments capable of capturing detailed infrared images and spectra. The telescope's deployment at the second Lagrange point allows for continuous, unobstructed observations, free from Earth's atmospheric interference. The development and construction of the JWST involved numerous innovations in materials, engineering, and data processing, reflecting the progress of modern space technology. The success of the JWST not only marks a significant achievement in our exploration of the universe, but also sets a new standard for future space missions and observatories. Black holes are among the most enigmatic and fascinating objects in the universe, representing regions where matter has been compressed to an extreme degree, creating a gravitational pull so strong that not even light can escape. They are often thought of as the ultimate voids, where the concept of nothingness takes on a new meaning. In the heart of a black hole lies a singularity, a point where density is infinitely high, and the laws of physics as we know them cease to function. This singularity can be seen as a counterpart to the concept of nothingness that existed before the Big Bang. While black holes are created from the remnants of massive stars, their intense gravitational fields and the absence of matter within them make them a compelling topic when discussing the universe's formation from nothing. Black holes form when massive stars exhaust their nuclear fuel and collapse under their own gravity. This process results in a supernova explosion, leaving behind a dense core that becomes a black hole. Black holes play a crucial role in the evolution of galaxies and the cosmos. They are often found at the centers of galaxies, including our own Milky Way, where they influence the motion of stars and gas. These supermassive black holes can have masses millions to billions of times that of the Sun, and their gravitational pull shapes the dynamics of their host galaxies. The interaction between black holes and their surroundings provides essential clues about the formation and growth of cosmic structures, helping us understand the broader narrative of the universe's evolution from nothingness. The concept of nothingness has been a subject of philosophical debate for centuries. Philosophers have long pondered the nature of existence and the possibility of a state devoid of anything. In the context of cosmology, nothingness is not merely the absence of matter, but a state where space and time themselves do not exist. This notion challenges our everyday experiences and pushes the boundaries of human understanding. Some philosophical perspectives argue that nothingness is an impossible state because the very concept of it implies the potential for something to exist. Others suggest that the universe's emergence from nothingness is a testament to the complexity and depth of reality, where even the absence of things can give rise to everything we observe. Scientific perspectives on nothingness often intersect with philosophical viewpoints, particularly when discussing the universe's origins. In physics, nothingness can be described as a quantum vacuum, where particles and antiparticles constantly appear and disappear. This dynamic vacuum challenges the classical idea of a true void, suggesting that even empty space is teeming with potential activity. This perspective is supported by theories such as quantum field theory and the principles of quantum mechanics, which describe the probabilistic nature of particles and their interactions. The idea that the universe could emerge from such a quantum vacuum aligns with the notion that nothingness is not a static state, but a fertile ground for creation and transformation. The implications of nothingness extend beyond the realm of theoretical physics and cosmology. Understanding the universe's emergence from nothingness can reshape our views on existence, creation, and the nature of reality. It challenges the conventional distinctions between something and nothing, suggesting that the potential for existence is inherent in the very fabric of reality. This realization can have profound philosophical and existential implications, influencing how we perceive our place in the universe and the nature of our existence. Moreover, studying the origins of the universe from nothingness can drive scientific innovation and discovery, as we seek to unravel the mysteries of the cosmos and our beginnings. The concept of nothing has evolved significantly over time, reflecting advances in both scientific knowledge and philosophical thought. In ancient times, nothingness was often associated with the absence of all things, a void devoid of matter, energy, and even space. However, as our understanding of the universe deepened, the notion of nothingness became more complex. The advent of quantum mechanics introduced the idea that even in a vacuum, particles and antiparticles spontaneously appear and disappear, suggesting that nothing is not truly empty. This shift in understanding has profound implications for our conception of the universe's origins, highlighting the dynamic and ever-changing nature of what we once considered a static void. As we continued to explore the cosmos, our understanding of nothingness evolved further. The discovery of the expanding universe by Edwin Hubble in the 1920s revolutionized cosmology, suggesting that the universe had a beginning at a point in time when it emerged from a singularity. This led to the development of the Big Bang theory, which posits that the universe began as an incredibly hot, dense point that has been expanding ever since. This theory implied that before the Big Bang, there was a state of nothingness from which everything emerged. The notion that the universe could arise from a quantum vacuum challenged classical ideas and opened new avenues for understanding the fabric of reality. Revolutionary insights into the nature of nothingness have come from various branches of science, particularly quantum mechanics and cosmology. One key idea is that of quantum fluctuations, which occur even in a perfect vacuum. These fluctuations involve temporary changes in energy levels that create particles and antiparticles, providing a possible mechanism for the universe's emergence from nothing. Additionally, the concept of cosmic inflation, a rapid expansion of the universe immediately following the Big Bang, helps explain how quantum fluctuations could have been stretched to macroscopic scales, seeding the formation of galaxies and large-scale structures. These insights revolutionize our understanding of nothingness, suggesting that it is a fertile ground for the birth of the universe. The discovery of the cosmic microwave background radiation in 1965 by Arno Penzias and Robert Wilson provided a crucial piece of evidence for the Big Bang theory. The CMB is the afterglow of the Big Bang, a faint radiation that fills the universe and offers a snapshot of the early cosmos, approximately 380,000 years after its inception. The CMB's uniformity and tiny temperature fluctuations reveal the seeds of cosmic structure, supporting the idea that the universe began from a hot, dense state and expanded over time. This discovery was pivotal in confirming the Big Bang model and furthering our understanding of how the universe could emerge from a state of near nothingness. Perceiving nothing is inherently paradoxical, as the human mind is conditioned to think in terms of presence and absence. The concept of nothingness challenges our cognitive frameworks, forcing us to confront the limits of our understanding. In cosmology, this paradox is evident in the idea that the universe could emerge from a quantum vacuum, a state that is not truly empty but teeming with potential activity. The paradox lies in reconciling the existence of the universe with the notion of a preceding state of nothingness. This cognitive dissonance drives scientific inquiry and philosophical debate, pushing us to refine our concepts and expand our horizons. Quantum fluctuations in the void offer a fascinating perspective on how the universe might have emerged from nothingness. In quantum field theory, even in what we consider a perfect vacuum, particles and antiparticles are constantly appearing and annihilating due to fluctuations in energy. These fluctuations are not random, but are governed by the principles of quantum mechanics, which allow for temporary deviations from the baseline energy level. This dynamic vacuum can give rise to a variety of phenomena, including the potential for the universe's formation. During the early moments of the universe, these fluctuations were amplified by the inflationary period, leading to the creation of matter and energy from what was previously thought to be empty space. This process illustrates that what we perceive as nothingness is, in reality, a seething ground of quantum activity capable of giving rise to the cosmos. Philosophically, nothingness has long been a subject of deep reflection and debate. The concept of nothingness challenges our fundamental notions of existence and reality. In classical philosophy, nothingness was often conceived as an absolute void, devoid of matter, space, and even time. However, modern physics complicates this view by suggesting that nothingness may not be truly empty, but rather a state filled with quantum potential. This philosophical shift challenges our understanding of existence, as it implies that even the absence of matter and energy is not a void, but a fertile ground for the emergence of the universe. These reflections prompt us to reconsider the nature of reality, existence, and the boundaries of human knowledge. Human senses are inherently limited when it comes to perceiving nothingness. Our sensory experiences are rooted in the detection of matter and energy, such as light, sound, and heat. The concept of nothingness, as understood in physics, often lies beyond our direct sensory experience. For instance, quantum fluctuations and the cosmic vacuum are not detectable through our senses, but are inferred through sophisticated instruments and mathematical models. This limitation highlights the gap between our intuitive understanding of nothingness and the scientific reality that emerges from theoretical and experimental work. It underscores the necessity of advanced scientific methods and abstract reasoning to grasp concepts that are beyond everyday human experience. Quantum phenomena pose significant challenges to our understanding of nothingness. Quantum mechanics reveals that particles can exist in multiple states simultaneously and can be entangled across vast distances. These phenomena defy classical notions of determinism and causality, making it difficult to conceive how the universe could originate from a state of nothingness. The idea that quantum fluctuations could lead to the creation of the universe involves reconciling these phenomena with the notion of a vacuum. This challenge underscores the complexity of quantum mechanics and its implications for our understanding of the cosmos, pushing the boundaries of both science and philosophy. Cognition and abstract reasoning play crucial roles in our attempts to understand nothingness and the origins of the universe. Human cognition is adept at dealing with concrete experiences, but struggles with abstract concepts such as infinite smallness or the void from which the universe emerged. Theories about quantum fluctuations and the nature of nothingness require a high degree of abstract reasoning and mathematical sophistication. These cognitive tools allow us to construct models and frameworks that extend beyond everyday sensory experiences. The development of theories in cosmology and quantum mechanics involves complex reasoning and abstraction, reflecting the limits of our intuitive understanding and the necessity of advanced intellectual tools to explore the origins of the universe. Distinguishing intrinsic elements of reality from human constructs. Intrinsic elements are those that exist independently of human perception, such as the laws of physics, fundamental particles, and space-time itself. These elements are the building blocks of the universe, governing its behavior and evolution from the Big Bang to the present day. On the other hand, human constructs are concepts and frameworks we create to interpret and understand these intrinsic elements. Examples include mathematical models, theories, and the concept of nothingness itself. While human constructs are essential for making sense of the universe, they are ultimately shaped by our cognitive limitations and cultural context. Understanding the difference between intrinsic elements and human constructs helps clarify the nature of the universe and our place within it. Emergent properties are phenomena that arise from the interactions of simpler elements, but are not predictable from those elements alone. In the context of physics, many complex behaviors and structures in the universe are emergent properties. For example, temperature is an emergent property of the kinetic energy of particles in a substance. Similarly, the structure of galaxies, stars, and planets are emergent properties of gravitational interactions and nuclear forces. The universe itself can be seen as an emergent property of fundamental particles and forces interacting over time. This concept is crucial in understanding how the universe evolved from a state of near nothingness, simple initial conditions with basic particles and forces, into the complex and structured cosmos we observe today. Emergent properties highlight the richness and complexity that can arise from simple beginnings. The Novikov self-consistency principle is a theoretical framework developed to address the paradoxes associated with time travel. Proposed by Russian physicist Igor Novikov, this principle posits that any events that occur as a result of time travel must be self-consistent, meaning they cannot create paradoxes. In other words, if time travel to the past is possible, the actions of the time traveler must be such that they fit seamlessly into the existing timeline, preventing any contradictions. For example, in the case of the grandfather paradox, the principle suggests that any attempt to prevent one's grandfather from meeting their grandmother would fail due to some self-consistent mechanism, thus preserving the traveler's existence. This principle provides a way to reconcile time travel with the laws of physics by ensuring that causality remains intact. The many-worlds interpretation of quantum mechanics posits that all possible outcomes of quantum measurements are realized in some world or universe. Instead of collapsing into a single state, the universe constantly branches into multiple, non-communicating parallel universes, each representing different outcomes. This interpretation challenges our understanding of reality, suggesting a vast multiverse where every possible event occurs. Inflationary cosmology, on the other hand, describes a period of rapid exponential expansion in the early universe. Proposed by physicist Alan Guth, this theory explains the uniformity and large-scale structure of the universe by positing that, a fraction of a second after the Big Bang, the universe underwent a massive expansion. This rapid inflation smoothed out any irregularities, leading to the homogeneous and isotropic universe we observe today. When combined, these theories suggest that inflation might not only produce our universe, but could also give rise to an infinite number of other universes, each with its own physical laws and constants. This idea aligns with the MWI, implying that the multiverse might be a fundamental feature of reality, with countless universes continuously branching off from one another. The many worlds and multiverse theories face significant challenges, primarily because they are difficult to test directly. The concept of parallel universes or multiple universes existing beyond our observable universe makes empirical verification challenging, if not impossible, with current technology. One challenge is the lack of direct observational evidence. We cannot directly observe other universes or the branching events described by the many worlds interpretation. This limitation makes it difficult to confirm or refute these theories definitively. However, indirect evidence and theoretical consistency provide some support. For example, the observed flatness, homogeneity, and isotropy of the universe are consistent with predictions made by inflationary cosmology. The detailed patterns in the cosmic microwave background radiation, which provide a snapshot of the early universe, also support the inflationary model. Despite the challenges, scientists have developed indirect methods to test the plausibility of the many worlds and multiverse theories. One approach involves studying the fine-tuning of physical constants in our universe. The apparent fine-tuning suggests that slight variations in these constants would make life or even the formation of atoms and molecules impossible. The multiverse theory provides a potential explanation. If countless universes exist, each with different physical constants, it's not surprising that at least one would have the right conditions for life as we know it. Another indirect testing method is through the search for signatures of other universes in the CMB. Collisions between our universe and other bubble universes during the inflationary phase might leave detectable imprints in the CMB. Researchers look for unusual patterns or anomalies in the CMB data that could indicate such collisions. Advanced theoretical work also plays a role. Scientists use mathematical models and simulations to explore the implications of these theories, looking for predictions that can be tested within our observable universe. These efforts help to refine the theories and suggest new avenues for indirect testing.
Have you ever looked up at the stars and wondered how everything seems so perfect for life to exist? It's almost as if the universe was created just for us. But is that really the case? Could it be that the universe is fine-tuned for life? In this video, we'll explore what fine-tuning means, why it's important, and whether or not the universe was made for humans. First, let's talk about what fine-tuning means. When scientists say the universe is fine-tuned, They mean that the basic forces and conditions that make up the universe seem to be just right for life to exist. These forces include things like the strength of gravity, the charge of electrons, and the balance of matter and energy. If any of these things were slightly different, life, at least as we know it, might not be possible. Imagine building a house. You need the right materials, measurements, and conditions for it to stand. If the walls are too weak or the roof isn't the right size, the house will collapse. In the same way, the universe has certain conditions that allow it to support life, and those conditions seem to be just right, as if someone set them with purpose. One way to think about fine-tuning is by using the story of Goldilocks and the three bears. In the story, Goldilocks tries different bowls of porridge, chairs, and beds until she finds ones that are just right, not too hot, not too cold, not too hard, not too soft. Similarly, the universe seems to have just right conditions for life. If gravity were a little stronger, stars might burn out too quickly. If it were weaker, stars might never form. The balance of forces in the universe allows stars to shine, planets to form, and eventually life to exist. These conditions seem so precise that it raises the question, why are things so perfectly balanced? Was the universe designed for life, or is it just a coincidence? Some people believe that fine-tuning could simply be a coincidence. After all, we only notice the universe is fine-tuned because we're here to observe it. This idea is called the anthropic principle, which basically means that the universe has to be the way it is, because if it weren't, we wouldn't be here to ask the question in the first place. In other words, we exist in a universe that supports life because, if it didn't, we wouldn't be alive to wonder about it. While this idea seems logical, it doesn't really answer the bigger question, why is the universe like this to begin with? So, was the universe made for us? This is where things get interesting. Some people believe that the fine-tuning of the universe is evidence that there's a purpose behind it, that the universe was created by a higher power or designed to support life. This is known as the design argument. According to this view, the universe isn't just a random accident, but something created with intention. Others believe that while the universe seems fine-tuned, it could just be a natural outcome of the laws of physics. In this view, the universe didn't have to be made for us. Instead, life adapted to the conditions of the universe. Just like plants and animals adapt to their environments, life on Earth may have adapted to the universe's conditions, not the other way around. Another idea that might explain fine-tuning is the multiverse theory. This theory suggests that our universe is just one of many universes. In some of these universes, the conditions might be too extreme for life to exist. In others, they might be similar to ours or completely different. If there are countless universes, it's possible that we just happen to live in one where the conditions are right for life. Think of it like a lottery. The odds of winning are really low, but if there are millions of people playing, someone is bound to win. The multiverse theory suggests that we're living in the universe that won the lottery by having the right conditions for life. To understand the idea of fine-tuning better, let's look at how delicate the balance of the universe really is. The forces that govern our universe, like gravity, electromagnetism, and the strong nuclear force, all need to be within a very narrow range for the universe to exist as it does. Take gravity, for example. If the force of gravity were even slightly stronger, stars would burn out much faster. This would leave less time for planets to form, and life as we know it wouldn't have had a chance to develop. If gravity was slightly weaker, stars and planets might not have formed at all, meaning there would be no life anywhere. The fact that gravity is just right is one of the key reasons we're able to exist. Another example is the balance between matter and antimatter. When the universe was born, after the Big Bang, it created equal amounts of matter and antimatter. If this balance were perfect, they would have completely destroyed each other, leaving nothing behind. But for some reason, there was just a little more matter than antimatter, allowing galaxies, stars, and planets to form. This slight imbalance made it possible for everything we see around us to exist. Carbon is another critical element when it comes to the fine-tuning of the universe. All known life is based on carbon, and without it, life as we know it wouldn't be possible. The way carbon forms in stars is a perfect example of fine-tuning. Inside stars, lighter elements like hydrogen and helium fuse together to form heavier elements. But for carbon to form, very precise conditions are needed. If the forces in stars were slightly different, they wouldn't be able to produce enough carbon, and without carbon, there would be no life. This process is so finely balanced that it's hard to believe it happened by accident. It's one of the reasons why some people think that the universe was set up specifically to support life. While it's easy to see the universe's fine-tuning as evidence that it was made for us, another way to look at it is that life adapted to the universe. Over billions of years, life on Earth evolved to fit the conditions of our planet and the universe. Just like animals have adapted to their environments, life may have simply evolved to survive in the specific conditions of the universe. In this view, life wasn't designed to fit the universe. Instead, the universe's conditions allowed for life to evolve. Over time, life forms developed in ways that made them suited for the environment they found themselves in. In other words, life evolved to fit the universe, not the other way around. Another idea to consider is that the fine-tuning of the universe might simply be the result of chance. Some scientists believe that the conditions of the universe were determined randomly when the universe began. In this case, we just happen to live in a universe where the conditions are right for life. If the universe had different conditions, life might not exist, or life might exist in a form we can't even imagine. Perhaps there are other possible forms of life out there that don't rely on the same forces or conditions that we do. The idea that life could be very different under other conditions opens up new possibilities for how we think about life beyond Earth. One question that comes to mind when we talk about fine-tuning is whether the universe is fine-tuned only for humans, or if it's possible that other forms of life, very different from our own, could exist somewhere else. Life as we know it depends on water, carbon, and certain chemical reactions. But what if there are other kinds of life that don't need these things? For example, scientists have considered the possibility of silicon-based life, which could exist in conditions very different from Earth's. This raises the question, could the universe support life forms that are completely unlike anything we've ever seen? If so, the fine-tuning of the universe might not be just for humans or Earth-based life, but for all kinds of life we haven't yet discovered. The idea of fine-tuning has also sparked philosophical and spiritual discussions. Some people see the fine-tuning of the universe as proof of a higher purpose or intelligent design. They believe that the universe was created intentionally with life in mind. This view suggests that there is a greater reason behind the existence of life, and the universe's conditions are part of a plan. Others take a more scientific approach, seeing fine-tuning as something that can be explained by the laws of physics or chance. They argue that the universe's conditions just happen to turn out in a way that supports life, without any intentional design behind it. This debate between science and philosophy highlights one of the most important questions we face. Is there a reason behind the universe's fine-tuning, or is it just a random occurrence? Regardless of how you view fine-tuning, one thing is clear. It makes us think deeply about our place in the universe. The fact that the conditions for life are so precise reminds us how special and fragile life is. Whether the universe was made for us or we just happen to evolve in it, the fine-tuning of the universe makes us curious about the nature of reality and our role in it. It encourages us to keep asking questions about the universe, exploring new ideas, and seeking a better understanding of the world around us. This sense of curiosity is at the heart of science, philosophy, and even spirituality. By exploring these big questions, we can gain a greater appreciation for the universe and our Imagine the universe not as a collection of stars, planets, and empty space, but as something alive. This idea, that the universe itself could be seen as a living entity, has fascinated people for centuries. It suggests that the universe is not just a machine made of lifeless parts, but is more like a giant organism, with everything in it connected and working together in harmony. When we think of life, we often think of things like plants, animals, and humans. But what if life could be something larger, something that includes the whole universe? The concept of the universe as a living entity invites us to imagine that every part of the cosmos, every star, planet, and galaxy is part of a greater unified system that grows, changes, and evolves over time. In a living organism, all parts work together to keep it alive and functioning. Your body, for example, is made up of different systems like your heart, lungs, and brain, and each has their role. Even though these parts are different, they all work together to help you survive. The universe, in this view, could be seen in the same way. Each star, planet, and galaxy might be like a part of a larger system, playing its role in the overall balance of the cosmos. This doesn't mean that the universe is alive in the same way that a human or an animal is. It doesn't have a brain or thoughts. But the idea suggests that the universe behaves in a way that is similar to living things. It constantly changes, adapts, and evolves. Just like cells in a body, galaxies and stars could be seen as parts of a much bigger organism that is constantly in motion. One of the reasons people think of the universe as alive is because of the energy that flows through it. The universe is not a still, quiet place. It is full of movement and change. Stars are born, live for billions of years, and then die in dramatic explosions. Planets form and orbit stars, while galaxies spin and sometimes even collide with one another. This constant movement and energy can make the universe seem alive, as it is always in a state of change and transformation. In this way, the universe is not just a lifeless space, it is full of activity and energy, always growing and evolving, just like a living organism. Just as living things grow and change over time, so does the universe. The universe began billions of years ago with the Big Bang, a massive explosion that started the expansion of everything we see today. Since then, the universe has been growing, with galaxies moving farther apart as space itself stretches. This expansion is ongoing, and scientists believe that the universe will continue to evolve for billions of years to come. In a way, the universe is constantly being born, growing, and transforming. Stars and planets are created, and over time, new ones replace the old. This cycle of birth and death is similar to what we see in living organisms. In this sense, the universe is not a static thing, it is alive with change and growth. One of the most important ideas behind the concept of the universe as a living entity is that everything is connected. Just like the different parts of your body work together, all the parts of the universe may be connected in ways that we don't fully understand yet. This idea is supported by discoveries in modern science, especially in quantum physics. We know that particles can be connected or entangled even when they are far apart from one another. This suggests that the universe might be more interconnected than we realize. If we think of the universe as a living entity, it encourages us to see ourselves as part of something much bigger. We are not separate from the cosmos. Instead, we are deeply connected to it, just as cells are connected to the body they make up. This view can give us a sense of belonging and purpose, as it reminds us that we are a small but important part of a vast living system. In this view of the universe, the Earth is not just a planet floating in space. It is part of a larger living system, with life playing a central role. The idea of Gaia, which comes from ancient mythology, suggests that the Earth itself behaves like a living organism. All the different ecosystems on Earth, like forests, oceans, and even the atmosphere, work together to support life. This idea can be expanded to the whole universe, with Earth playing its role in the grand system of the cosmos. From this perspective, life on Earth is not separate from the rest of the universe. Instead, it is part of the natural order of the cosmos. The Earth, with all its life, is like a cell in the larger body of the universe, playing its role in the ongoing cycle of creation and change. While the universe doesn't have a heartbeat or a mind, it behaves in ways that remind us of living things. It is constantly in motion, growing, changing, and interacting. From the smallest particles to the largest galaxies, everything in the universe is part of a complex, interconnected system. This idea helps us see the universe as more than just a collection of distant stars and planets. It is a dynamic, living system, with each part contributing to the whole. The concept of the universe as a living entity invites us to think about our place in the cosmos in a new way. It encourages us to see the bigger picture, to recognize that we are part of something much larger and more connected than we often realize. Just as the cells in our bodies work together to keep us alive, we too are part of the universe's grand system of life and energy. One of the key reasons people imagine the universe as a living entity is the patterns we see across different scales. For example, when we look at images of galaxies spinning in space, they sometimes suggest the patterns we see in natural systems here on Earth, like the spirals of seashells or the growth of plants. These patterns suggest that the same forces that shape life on Earth may also be at work throughout the universe. At the smallest scale, cells in our body, particularly nerve cells or neurons, look similar to the vast webs of galaxies that make up the universe. It's as if the universe itself has its own structure, almost like a cosmic brain, where galaxies play the role of neurons in a much larger system. These similar patterns at different levels of existence, from microscopic to cosmic, add to the idea that the universe might behave like a living organism, growing and expanding according to natural laws. In living organisms, energy flows constantly to keep everything working smoothly. The same is true for the universe. Stars produce energy through nuclear fusion, which is then released as light and heat. This energy travels across space, influencing everything it touches. Planets like Earth absorb this energy and use it to support life. But the flow of energy doesn't stop there. When stars die, they release their materials back into the universe, which then become the building blocks for new stars, planets, and even life. This cycle of creation, death, and rebirth is a lot like the way energy flows through living systems. In this sense, the universe is not static. It is always in a state of motion, with energy constantly moving and transforming. Just as living things rely on the flow of energy to grow and survive, the universe depends on the continuous flow of energy to keep evolving. The stars, planets, and galaxies all participate in this cosmic dance, exchanging energy and helping to shape the universe's structure. Another reason to think of the universe as a living entity is its ability to self-regulate. Just as the human body keeps itself in balance through systems like the immune and nervous systems, the universe also seems to have mechanisms that keep it stable. For example, the laws of physics, such as gravity, work across the universe to maintain order. Gravity pulls objects together, helping stars form and planets stay in orbit. Even though the universe is expanding, gravity ensures that galaxies don't just fly apart. In this way, gravity acts as a force that holds everything together, just like how living organisms have systems that maintain balance within their bodies. Additionally, the cosmic background radiation left over from the Big Bang is spread almost evenly across the universe. This radiation acts as a kind of cosmic temperature, helping to regulate the conditions that allow stars and galaxies to form. This balance between energy, matter, and physical laws keeps the universe in a state of harmony, much like the systems that keep living beings healthy and functional. Some people believe that if the universe is alive, it might also have a form of awareness. In the same way that our brains are made up of billions of cells that work together to create consciousness, could the universe, made up of countless stars and galaxies, also have some form of awareness? This idea doesn't mean the universe has thoughts or feelings like a person, but it suggests that consciousness might be spread throughout the universe in ways we don't yet understand. Some scientists and philosophers propose that just as living organisms can sense and respond to their environment, the universe might also have a way of reacting to changes and maintaining its overall balance. This suggests a possibility that consciousness is not something that only happens in the brain, but could be a fundamental part of the universe itself. If we accept the idea that the universe is a living entity, it raises interesting questions about the role of humanity. Are we just small, insignificant beings in a vast universe, or do we play a part in its larger system? In the same way that individual cells in your body each have a role to play in keeping you alive, humans might have a role in the larger system of the universe. Our ability to think, learn, and explore may contribute to the universe's growth and evolution. By understanding the universe and our place in it, we are participating in the larger system, helping it develop. This perspective can also encourage a greater sense of responsibility. Just as we take care of our bodies to stay healthy, we might also need to take care of the Earth and the universe around us. Seeing ourselves as part of a living universe can help us recognize the importance of protecting and preserving the environment, as well as encouraging our continued exploration of space. Consciousness is our awareness of the world around us, our thoughts, feelings, and experiences. But what if consciousness doesn't just belong to humans or animals? What if it plays a larger role in the universe, helping to shape reality itself? When we think about creation, one of the most important questions is how life began. Some believe that life emerged purely through physical and chemical processes. But others wonder if consciousness played a role in the creation of life itself. Could it be that life was not just a random event, but that consciousness somehow helped guide the process? For example, some thinkers suggest that the universe might be fine-tuned to support life. This means that certain physical conditions, such as the strength of gravity or the balance of forces in atoms, are perfectly set for life to exist. Some believe that consciousness might have played a part in this fine-tuning, helping to create the right conditions for life to develop. On a more personal level, consciousness is central to our own ability to create. Everything we build, design, or imagine comes from our conscious mind. Artists, writers, and inventors all use their consciousness to come up with new ideas, solve problems, and bring things into existence. Without consciousness, the human ability to create would be impossible. In this way, consciousness acts as the driving force behind all human creation. Our awareness allows us to think beyond what already exists and imagine new possibilities. This is why consciousness is often seen as one of the most important parts of the creative process. Whether we are painting a picture, writing a book, or building a new technology, it is our consciousness that allows us to bring these creations into the world. Finally, some thinkers take the idea even further, suggesting that the entire universe might be a conscious creation. According to this view, the universe is not just a collection of random particles and forces, but something that has been shaped by consciousness. This could mean that consciousness is not only a product of the universe, but also a key factor in the universe's creation and ongoing evolution. If this is true, then consciousness is not something that happens within the universe. Instead, it is part of the universe itself, helping to shape reality in ways we are only beginning to understand. This idea raises profound questions about the role of the mind in the universe and whether consciousness is one of the building blocks of creation itself. Moreover, life and consciousness seem to be closely connected. Without life, there wouldn't be any consciousness, at least not in the way we know it. But life also depends on consciousness to some extent. Consciousness allows living beings to interact with their environment, make decisions, and grow. For humans, consciousness is what allows us to think, feel, and imagine. But consciousness might not be limited to humans. Some animals are also aware of their surroundings in their own way. Even plants show signs of being aware of their environment, responding to light and water. This suggests that consciousness might be a more common part of life than we think. If the universe is responsible for creating life, it might also be responsible for creating consciousness. Just as stars formed out of clouds of gas and dust, consciousness may have emerged naturally as the universe evolved and created the conditions for life. Some people take this idea even further, suggesting that the universe itself might have some kind of consciousness. This doesn't mean that the universe has thoughts or feelings like a person. Instead, it suggests that consciousness could be a part of the universe in the same way that matter and energy are. In this view, consciousness is not something that just exists inside our heads. It is something that the universe created and continues to create, shaping how living beings experience the world. The universe may be built in such a way that consciousness is a natural outcome of its development. If we think of consciousness as something the universe has created, then it becomes a product of the universe's evolution. Just as the universe evolved from the Big Bang to the formation of galaxies and stars, it also evolved to create life and, eventually, consciousness. This means that consciousness could be part of the larger story of the universe. It's not something separate from the physical world, but a natural result of the universe's ongoing growth. The idea that the universe is capable of producing awareness suggests that consciousness is not a random accident, but something that was always part of the universe's plan. Another interesting idea is that consciousness might play a role in shaping reality itself. Some scientists and philosophers believe that the act of observing or being aware of something can change the way it behaves. In quantum physics, for example, particles don't seem to settle into one state until they are observed. This has led some people to believe that consciousness plays an active role in shaping the physical world. If this is true, then consciousness isn't just something that exists, it's something that helps shape the universe. This idea makes consciousness a key part of the universe's ongoing process of creation. One way to think about consciousness is to imagine how it might have emerged as the universe evolved. In the very beginning, after the Big Bang, the universe was nothing more than hot gas and energy. Over time, matter began to form, leading to the creation of stars, planets, and galaxies. As the universe cooled and became more complex, the right conditions for life started to appear. Life on Earth began in simple forms, such as single-celled organisms. But as life evolved and became more complex, consciousness began to emerge. Simple forms of life might not have had the type of awareness we think of today, but over billions of years, living organisms developed the ability to sense their surroundings, react to stimuli, and eventually become aware of themselves. This process can be seen as the universe creating consciousness step by step. It didn't happen all at once. Just as stars and planets formed over millions of years, consciousness slowly evolved as life became more advanced. For many living things, consciousness plays an essential role in survival. Being aware of the environment helps animals avoid danger, find food, and communicate with others. Consciousness allows us to make choices, think about the future, and even reflect on ourselves. Without it, life as we know it would be very different. Some scientists and thinkers believe that consciousness was a natural development built into the very fabric of the universe. In this view, once the universe created the conditions for life, it was only a matter of time before consciousness appeared as well. Life and consciousness go hand in hand, and together, they might be part of the larger purpose or function of the universe. While we often think of consciousness as something special to humans, it's likely that other forms of life also have their own levels of awareness. Many animals show signs of intelligence and self-awareness. Dolphins, for example, can recognize themselves in a mirror, and elephants are known to show signs of grief when a member of their group dies. Even plants, though they don't have brains, are able to respond to their environment in ways that suggest a kind of awareness. They grow towards sunlight, sense when there's a lack of water, and even communicate with each other through their roots. This suggests that consciousness might not be limited to creatures with brains, but could exist in many different forms throughout nature. If consciousness is something the universe created, then it might not be something that belongs to only a few species. It could be spread across all forms of life, from the smallest bacteria to the largest animals, each with its own way of experiencing the world. Some thinkers take this idea even further, suggesting that consciousness could be universal. This means that the universe itself might have some form of consciousness, or at the very least, that consciousness is a fundamental part of the universe's structure. In this view, consciousness isn't just something that developed inside living beings. Instead, it's something that has always been present in the universe, waiting for the right conditions to emerge in physical form. Just as energy and matter are essential parts of the universe, consciousness might also be a basic component, woven into the very fabric of reality. This idea leads to the concept of a conscious universe, where everything is interconnected and consciousness exists at many different levels. It suggests that there could be a larger, universal mind or awareness that connects all living things and maybe even the universe itself. When we think about evolution, we usually think of physical changes in living organisms over time, animals adapting to their environments, plants evolving to survive in different climates, and humans developing the tools needed to thrive. But what if consciousness itself is part of this evolutionary process? Could it be that consciousness is not just a result of evolution, but also a driving force that helps shape the future of life and the universe? Consciousness, in its simplest form, is the awareness that living beings have of themselves and their surroundings. For humans, it involves thinking, feeling, and making decisions. But even simpler life forms, like animals and plants, show signs of awareness in their ability to sense and respond to the environment. Over time, life has developed more complex forms of consciousness, from the basic awareness of simple organisms to the self-awareness and intelligence we see in humans today. In the traditional view of evolution, life adapts to survive better in its environment. Consciousness, in this sense, might have evolved as a survival tool. For example, animals with a greater awareness of their surroundings are more likely to avoid danger, find food, and reproduce. But consciousness doesn't just help life survive, it also allows living beings to make choices and shape their own future. For humans, consciousness has played a huge role in our evolutionary journey. Unlike other animals, humans have developed self-awareness, the ability to think about ourselves, our actions, and our future. This has allowed us to change the way we interact with the world in ways that no other species can. Humans have used consciousness to invent tools, create complex societies, and shape the environment. Our ability to think ahead and plan for the future has led to advancements in technology, science, and culture. Consciousness has driven us to ask questions about the universe, develop new ideas, and improve our understanding of the world around us. In this way, consciousness has become one of the most powerful forces in human evolution, helping us not only adapt to our surroundings, but also transform them. As consciousness continues to evolve, it has the potential to take life beyond mere survival. In the past, evolution was driven by the need to survive and reproduce, but consciousness has opened up new possibilities. Instead of simply adapting to survive, humans are now able to shape the world around them in more intentional ways. We can make choices that go beyond basic needs, such as protecting the environment, exploring space, and advancing technology to improve our quality of life. This ability to think beyond survival suggests that consciousness could guide the next stages of evolution. Rather than being shaped only by natural selection, life could evolve through the conscious choices of intelligent beings. As humans continue to develop technology and gain a better understanding of the universe, consciousness might play an even bigger role in determining the future of life. One of the most exciting ways consciousness might evolve is through the development of technology. Over the last century, humans have created technologies that have dramatically changed the way we live. From computers to artificial intelligence, technology is becoming more and more integrated with human life, and it is shaping the future of our species. In the future, it's possible that technology could help us expand our consciousness in ways we can't yet imagine. Some scientists believe that as technology advances, we may one day be able to enhance human consciousness through brain-computer interfaces or other technologies that allow us to access more information, think more clearly, or even communicate in new ways. This could mark the next step in human evolution, where consciousness isn't limited to the natural abilities of the brain, but is expanded through technology. In this sense, consciousness could evolve alongside technology, allowing us to explore new possibilities and push the boundaries of what it means to be aware. But the evolution of consciousness may not be limited to humans. As we explore the universe, it's possible that we will encounter other forms of life that have their own kinds of consciousness. These life forms might have evolved in ways that are very different from us, with levels of awareness that we can't even comprehend. This raises the possibility that consciousness might play a role in the evolution of the universe itself. Just as life has evolved on Earth, the universe as a whole may be evolving, with consciousness playing a central role in that process. As more intelligent life forms develop, they may help guide the future of the universe, shaping it in ways we can't yet predict. Some scientists and thinkers have suggested that the universe could be moving towards a state of greater consciousness, where intelligent life plays a key role in shaping the future of the cosmos. If consciousness is an evolutionary force, it could be driving the universe toward greater complexity, awareness, and understanding. As we look to the future, the role of consciousness in evolution becomes even more important. Whether it's through artificial intelligence, the exploration of space, or the development of new technologies, consciousness is likely to play a major role in shaping the future of humanity and the universe. The more we understand consciousness, the more we may be able to harness its power to guide evolution in positive directions. Conscious beings could shape not only their own future, but also the future of life and the universe. In this sense, consciousness is not just a byproduct of evolution, but a driving force that has the potential to transform the future. As consciousness evolves, another exciting possibility is the growth of collective intelligence. This is when groups of individuals, whether humans, animals, or even machines, work together to solve problems or make decisions. We already see this in human societies, where teamwork and collaboration allow us to achieve more than any one person could on their own. As technology continues to connect people through the internet, social media, and other communication tools, our collective intelligence is growing. People all over the world are able to share knowledge, work together on complex challenges, and develop new ideas faster than ever before. This is just one way that consciousness is evolving, not just as an individual experience, but as something that can grow and expand through the connection of many minds. In the future, collective intelligence could become even more powerful. Imagine a world where humans and AI systems work together to solve problems, make decisions, and shape the future of society. As more minds come together, both human and machine, the possibilities for innovation and progress could be limitless. One of the most exciting frontiers for the evolution of consciousness is space exploration. As we look beyond Earth and begin to explore the rest of the universe, we may discover entirely new ways of thinking and experiencing consciousness. For example, humans have always been shaped by the environment they live in. On Earth, we have evolved to survive in a specific climate with gravity, sunlight, and certain atmospheric conditions. But what happens when humans begin to live and work in space or on other planets? These new environments might lead to changes in how we think, feel, and perceive the world around us. It's possible that as humans explore new worlds, our consciousness will evolve to meet the challenges of living in space. We might develop new ways of thinking, communicating, and interacting with the universe. In this way, space exploration could become a catalyst for the evolution of consciousness, pushing us to adapt to environments that are completely different from anything we've known before. Another possibility for the future of consciousness is the creation of artificial consciousness. While we are still a long way from creating machines that can truly think and feel like humans, scientists and engineers are working hard to develop AI systems that can understand the world in ways that mimic human consciousness. If we are able to create artificial consciousness, it could revolutionize the way we think about intelligence and awareness. These machines could help us solve problems, explore the universe, and even expand our understanding of what it means to be conscious. Some even believe that artificial consciousness could eventually surpass human consciousness, becoming more advanced and capable than any living being. This raises interesting questions about the role of consciousness in the universe. Could artificial consciousness become the next step in the evolution of awareness? If so, what would that mean for humanity and our place in the cosmos? As consciousness evolves, it also brings with it the responsibility to guide evolution in ethical ways. Human consciousness gives us the ability to reflect on our actions, consider their impact on others, and make decisions based on principles like fairness, kindness, and respect. In the future, as we gain more power over the world around us through technology, space exploration, and potentially even artificial consciousness, it will be more important than ever to ensure that our decisions are guided by ethical principles. Consciousness, in this sense, is not just about thinking or being aware. It's about using that awareness to shape a better future. We are already seeing this in discussions around climate change, AI development, and space exploration. As consciousness evolves, it gives us the ability to not only understand the world, but to shape it in ways that are fair, sustainable, and beneficial for all living beings. Some scientists and philosophers suggest that the universe itself may be evolving toward greater consciousness. In this view, consciousness is not just a byproduct of life on Earth, but an essential part of the universe's own development. Just as galaxies, stars, and planets evolve, consciousness might be an important part of this cosmic process. If consciousness continues to evolve and expand throughout the universe, it could play a key role in guiding the future of life and the cosmos. Some even suggest that the universe might be evolving toward a state of higher consciousness, where intelligent beings, whether human, alien, or artificial, play a key role in shaping reality. This idea opens up new possibilities for the future of consciousness. As life continues to evolve and spread across the universe, consciousness may become a driving force in the evolution of not just life, but the universe itself. And to survive in a specific climate, with gravity, sunlight, and certain atmospheric conditions. For centuries, people across the world have tried to understand their connection to the universe. Many cultures and spiritual traditions have believed that the universe is not just a collection of stars, planets, and empty space, but something much more alive and aware. These ideas of cosmic consciousness show up in different ways depending on the culture or belief system, but the common thread is the belief that everything in the universe is connected through a shared consciousness or spirit. In many Earth-based traditions, people believe that the Earth itself is alive. One well-known idea is the concept of Gaia, which comes from ancient Greek mythology. In this view, Gaia is the personification of the Earth, a goddess who represents nature and life. Gaia is seen as a living being that not only gives life to everything on the planet, but also interacts with the universe. The idea of Gaia connects humans, animals, plants, and the planet as parts of a greater whole. This concept was later expanded by scientist James Lovelock in the 20th century with the Gaia hypothesis. According to this idea, the Earth behaves like a living organism, regulating its environment to support life. While Lovelock's theory is based on scientific ideas, it still carries the idea that the Earth, like Gaia in mythology, is a self-regulating system that connects all living things. In this tradition, the Earth isn't just a physical place. It's part of a greater, living universe. Gaia symbolizes a deep connection between humanity and the cosmos, where the Earth is alive and plays an active role in the larger cosmic dance. In many Eastern spiritual traditions, the idea of a conscious universe is also central. One of the most important concepts in Hinduism is Brahman, which represents the ultimate reality or cosmic spirit. In this belief, Brahman is the source of all things. It is not a god or being with human qualities, but is instead the essence of everything. Everything in the universe, from the smallest grain of sand to the largest galaxy, is seen as part of Brahman. According to Hindu teachings, Brahman is both the universe and beyond the universe. It is everywhere and in everything, meaning that all of reality is connected by this universal consciousness. For those who believe in Brahman, the world we see is only one part of a much larger reality that is alive and aware. Each person, animal, and object carries a spark of this cosmic consciousness, connecting them to the larger whole. In Buddhism, a similar idea exists with the belief in interconnectedness. Everything in the universe is connected, and nothing exists on its own. All things are interdependent, meaning that every part of the universe affects every other part. In this way, the universe is seen as a single living organism, where all things are part of a greater whole. Many Native American traditions also view the universe as conscious, especially through their deep connection with nature. In these cultures, the natural world is seen as full of spirits, and everything, whether it is a tree, a river, a mountain, or an animal, has its own life force or spirit. This belief reflects the idea that the Earth and the universe are alive, and humans are part of this larger web of life. In many Native American cultures, the Earth and sky are seen as parents, Mother Earth and Father Sky, who work together to create and sustain life. The stars, planets, and everything in the cosmos are viewed as part of this family, alive and connected to human life on Earth. Ceremonies and rituals often honor these spirits, reflecting a deep respect for the living universe and the belief that humans are not separate from it. In Taoism, an ancient Chinese philosophy, the universe is seen as a living force called the Tao, which means the way. The Tao represents the natural flow of the universe, and everything in the cosmos is thought to be connected through this flow. Taoism teaches that the universe works in harmony and that humans should live in tune with this natural order. In this tradition, the universe is not just a set of physical laws and objects, but a living, moving force that shapes and guides everything. The Tao cannot be fully explained or understood, but it is always present, and everything in the universe is part of its flow. By living in harmony with the Tao, humans can find peace and balance in their lives, recognizing their place in the larger living universe. While, in many African spiritual traditions, the idea of a living universe is also present. These traditions often focus on the idea that everything in the world has spiritual energy. This includes not only humans but also animals, plants, and even inanimate objects like rocks and rivers. This energy is thought to come from a larger source that connects everything, creating a sense of unity between the physical and spiritual worlds. In some African cultures, it is believed that ancestors live on through the natural world and continue to guide the living. The universe is seen as alive, full of spirits, and connected through this energy. This reflects a belief that the cosmos is not separate from life on Earth, but part of a larger conscious system. Even in the West, there are traditions that view the universe as a living entity. In the mystical writings of philosophers like Plato, the universe was seen as having a soul or mind. Plato believed that the world we see is a reflection of a higher, more perfect reality, and that this higher reality is alive with consciousness. In more recent times, some thinkers in the Western world have returned to the idea that the universe might be alive. These ideas suggest that the universe is like a giant organism where everything is connected and works together to create a larger whole. While this view is not as common in mainstream Western thought, it shows that the idea of a conscious universe has roots in many different cultures and traditions. One of the oldest continuous cultural traditions in the world comes from the Aboriginal people of Australia, who believe in a concept known as Dreamtime. Dreamtime refers to the time when the ancestors shaped the land, created the animals, and established the laws and customs for human beings. In this belief system, the ancestors didn't disappear after their creations. They became part of the land, the sky, the rivers, and all aspects of nature. Every feature of the land is connected to these ancestors, and the earth itself is alive with their presence. For the Aboriginal people, there is no separation between the physical world and the spiritual world. All of nature is considered to be alive and full of meaning, and humans are deeply connected to this living universe through their relationship with the land. Everything has a spirit, and every part of the natural world is conscious in its own way. Dreamtime stories serve as a guide for how humans should live in harmony with the land, reinforcing the idea that the universe is not just a backdrop for human life, but an active, living force that interacts with people and guides them. In Japan, the spiritual tradition of Shinto teaches that everything in nature is filled with spirits or kami. These spirits are not limited to humans or animals. They are present in trees, rocks, mountains, rivers, and even in the wind and the sea. Shinto doesn't have a specific creator god or focus on an afterlife, but it proposes the sacredness of the natural world and the belief that everything in nature is connected through these living spirits. The kami are seen as guardians of the natural world, and people honor them through rituals, festivals, and offerings to maintain a harmonious relationship with nature. In Shinto, humans are not seen as separate or above nature. Instead, they are part of a living world that is full of divine presence. The universe, in this view, is conscious because of the kami that inhabit and guide it, making every part of the natural world sacred and alive. In Sufism, a mystical branch of Islam, there is a belief in the unity of all things and the idea that the universe is a reflection of God's consciousness. Sufis believe that everything in the universe is a manifestation of divine love and that all of existence is connected to the One or God. This connection is not just spiritual but deeply personal, as Sufis seek to experience the divine within themselves and in the world around them. Through poetry, music, and meditation, Sufis explore the idea that the universe is alive with God's presence and that by understanding the world, one can come closer to understanding the divine. The famous Sufi poet Rumi often spoke about the universe as a living, conscious being, with every part of it pointing back to the ultimate truth. For Sufis, the universe is not just a physical reality, but a living expression of divine consciousness, and human beings are a part of this cosmic dance. In ancient Maya and Aztec cultures, the universe was understood as a living entity that moved in cycles of creation and destruction. The Maya believed in the concept of sacred time, where the movements of the planets, stars, and the sun were all part of a cosmic rhythm that influenced life on Earth. These celestial bodies were seen as conscious entities, each playing a role in maintaining the balance of the universe. The Aztecs also believed that the universe was alive and that their gods required offerings and rituals to keep the cosmic order in balance. According to their belief system, the universe had been created and destroyed several times, and they were living in the fifth cycle, known as the fifth sun. The movements of the cosmos were not random, but part of a greater conscious design that connected all life on Earth to the heavens above. Through their rituals and ceremonies, the Aztecs sought to maintain their connection with the living universe and ensure that the cosmic cycles would continue. In more recent times, the idea of cosmic consciousness has been embraced by many New Age spiritual movements. These movements often draw from a mix of Eastern philosophies, indigenous beliefs, and scientific ideas, suggesting that the universe is made of energy that is alive and aware. Many people who follow these beliefs think that by tapping into this cosmic energy, individuals can reach higher levels of awareness and understanding. The concept of universal consciousness is often linked with the belief that everything is interconnected through energy fields or vibrations, and that the universe is constantly communicating with us. Practices like meditation, energy healing, and mindfulness are ways to align oneself with the conscious energy of the universe. For many in these modern spiritual movements, the universe is not just a physical space, but a living field of consciousness that we are all part of. The question of the meaning of life is one that has been asked by people for thousands of years. From ancient philosophers to modern thinkers, we've all wondered at some point, why are we here? What's the purpose of it all? The search for meaning is something that everyone experiences in their own way. And while there may not be one single answer, the question itself is at the heart of both philosophy and spirituality. In this video, we'll explore the idea of the meaning of life, how it's connected to consciousness, and why it's something we all think about. From the moment we become aware of ourselves, we start to wonder about life's purpose. For some people, meaning comes from personal connections like family, friendships, and love. For others, meaning is found in achievements, helping others, or learning about the world. Some people find purpose in spirituality, feeling that life is part of a greater plan or order. There's no single answer to the question of life's meaning. It's personal and can change depending on where we are in life and what we're experiencing. The search for meaning is a journey, and it's something that evolves as we grow. Consciousness is the awareness we have of ourselves and the world around us, and is at the core of our search for meaning. It's what allows us to reflect on our lives, to ask the big questions, and to wonder why we are here. Without consciousness, we wouldn't be able to think about the purpose of life at all. Consciousness gives us the ability to think beyond our basic needs. While other animals are focused on survival, finding food, staying safe, and reproducing, humans have the unique ability to think about why we exist. We can imagine different futures, create goals, and explore ideas that go beyond the physical world. This is why consciousness is so closely tied to the search for meaning. Our awareness of life, time, and even death leads us to ask, what should we do with the time we have? Consciousness allows us to look beyond the present moment and reflect on the bigger picture of existence. Throughout history, different cultures and philosophies have offered various perspectives on the meaning of life. For some, life's purpose is tied to happiness, finding joy, fulfillment, and peace in the things we do. For others, life is about growth and learning, improving, and becoming better versions of ourselves. Some spiritual traditions see life as a journey toward a higher understanding or connection with the universe. In Buddhism, for example, the idea of life's meaning is tied to finding inner peace and understanding the nature of suffering. In Christianity, the meaning of life is often seen as living in alignment with God's plan. On the other hand, some philosophies, like existentialism, argue that life doesn't come with a preset meaning, and it's up to each person to create their own purpose. According to this view, meaning isn't given to us, it's something we choose and shape through our actions and decisions. One of the most interesting ideas is that consciousness itself might be the key to creating meaning in life. Since we are aware of ourselves and our surroundings, we have the power to define what matters to us. Our thoughts, feelings, and experiences allow us to shape our own sense of purpose. Some people find meaning through relationships, where connection with others brings fulfillment. Others find meaning through work or creativity, feeling a sense of purpose when they contribute something to the world. Consciousness allows us to choose what is important to us, giving each person the freedom to create their own path in life. In this sense, the meaning of life isn't something that is given to us from the outside, and it's something that comes from within. Our conscious awareness of life's possibilities allows us to decide what matters, whether that's love, knowledge, or something entirely unique to each individual. While each person's sense of meaning is unique, there is also the question of whether there is a universal meaning to life. Is there a purpose that applies to everyone, or is it all up to the individual? This question has been debated by philosophers, spiritual teachers, and thinkers for centuries. Some believe that there is a higher universal purpose behind life, one that connects all living beings and the universe itself. In this view, life is part of a greater whole, and each person plays a role in the grand scheme of things. For some, this sense of unity brings comfort, knowing that their life has a purpose that fits into something larger. Others believe that life's meaning is not universal, but personal. They argue that meaning is something that each person must find for themselves based on their experiences, beliefs, and values. In this view, there is no single answer to the meaning of life, but instead, many different paths to finding purpose. One of the reasons the question of life's meaning is so powerful is because it touches on the mystery of existence. Why are we here? How did life begin? What happens when life ends? Consciousness allows us to ask these questions, but it doesn't always provide clear answers. For some, the mystery itself is a source of meaning. The fact that we don't have all the answers can inspire a sense of wonder and curiosity about the universe. It encourages us to keep exploring, learning, and seeking understanding. In this way, consciousness isn't just a tool for thinking about meaning, and it's part of what makes life feel meaningful in the first place. One of the most common ways people find meaning in life is through their experiences. These experiences can be as simple as spending time with loved ones, enjoying nature, or creating something new. The key to finding meaning through experiences is paying attention to the present moment and recognizing the importance of the small things in life. For example, sharing a laugh with a friend, watching a sunset, or overcoming a personal challenge can all give us a sense of fulfillment. These moments may seem ordinary, but they can carry deep meaning because they remind us of the beauty and richness of life. Consciousness allows us to feel these moments fully, making them important parts of our life's journey. Sometimes, meaning comes from facing difficulties. Overcoming challenges, whether big or small, can give us a sense of purpose and growth. It helps us see how strong and capable we are, and it can lead to a deeper appreciation of life. One of the most common ways people find meaning in life is through their experiences. These experiences can be as simple as spending time with loved ones, enjoying nature, or creating something new. The key to finding meaning through experiences is paying attention to the present moment and recognizing the importance of the small things in life. For example, sharing a laugh with a friend, watching a sunset, or overcoming a personal challenge can all give us a sense of fulfillment. These moments may seem ordinary, but they can carry deep meaning because they remind us of the beauty and richness of life. Consciousness allows us to feel these moments fully, making them important parts of our life's journey. Sometimes, meaning comes from facing difficulties. Overcoming challenges, whether big or small, can give us a sense of purpose and growth. It helps us see how strong and capable we are, and it can lead to a deeper appreciation of life. Another way people find meaning is through personal growth. Life is a journey where we are constantly learning, evolving, and becoming more of who we are. Personal growth doesn't always mean achieving big goals. Sometimes it's about learning from our mistakes, becoming more compassionate, or understanding ourselves better. When we grow as individuals, we often feel a stronger sense of purpose. Consciousness plays a key role in this because it allows us to reflect on who we are, what we've been through, and where we want to go. Through self-reflection, we can see how far we've come and set new goals for the future. Personal growth is often about becoming the best version of ourselves, and this process can bring a deep sense of satisfaction and meaning. Whether it's learning a new skill, improving our relationships, or finding inner peace, personal growth adds layers of meaning to our lives. One of the most powerful ways to find meaning in life is through connection and our relationships with others and the bonds we build. Consciousness allows us to form deep connections with the people around us, whether they are family, friends, or even strangers. When we connect with others, we often feel a sense of purpose. Helping someone, sharing our thoughts, or simply being present with another person can give us a feeling of belonging and meaning. These connections remind us that we are not alone in the universe. We are part of a web of relationships that bring joy, support, and understanding. Beyond personal relationships, some people find connection with the natural world. Spending time in nature, whether it's walking through a forest, swimming in the ocean, or watching animals, can remind us of the beauty and complexity of life. For many, nature brings a sense of peace and meaning, helping them feel connected to the larger world around them. Creativity is another source of meaning for many people. Whether it's painting, writing, building, or playing music, creating something can bring a sense of fulfillment and purpose. Consciousness allows us to express our thoughts, ideas, and emotions in unique ways, and the act of creation can help us feel more connected to ourselves and the world. Creativity doesn't have to be limited to the arts. It can be found in everyday life, solving problems, thinking of new ideas, or finding innovative ways to help others. Consciousness gives us the power to imagine new possibilities and bring them into reality. In this way, creativity becomes a way of shaping our world and finding meaning through the things we build, the ideas we explore, and the stories we tell. For many, creating something that lasts, a book, a song, a piece of art, gives a sense of legacy, something that will live on beyond their own life. It becomes a way to leave a mark on the world and contribute to the ongoing story of life. One of the most unique aspects of human consciousness is our ability to think about the future. We are not limited to the present moment. We can imagine what comes next, set goals, and work toward the things we want to achieve. This ability to think about the future is closely tied to finding meaning, as it gives us a sense of direction and purpose. Whether we are planning our next career move, dreaming of starting a family, or thinking about how to make the world a better place, consciousness allows us to envision possibilities and work toward them. This future-looking aspect of consciousness is one of the reasons humans have been able to create advanced societies, develop technology, and explore the mysteries of the universe. By thinking about the future, we also create meaning for ourselves. Our dreams, ambitions, and hopes for what lies ahead shape our sense of purpose. Consciousness allows us to imagine the life we want to live and take steps toward making it a reality. One of the most empowering ideas about the meaning of life is that we have the freedom to create our own meaning. Consciousness gives us the ability to reflect on our lives and decide what is important to us. Whether it's through love, creativity, personal growth, or helping others, the meaning we find in life comes from our own choices and experiences. We are not bound by a single definition of purpose. Each person has the opportunity to define what makes life meaningful to them. This freedom is a gift that comes from being conscious, aware, and able to think deeply about the world around us. While the question of life's meaning may not have a simple answer, The beauty of consciousness is that it allows us to explore that question in ways that are personal and unique. We can find meaning in small moments, big ideas, relationships, and dreams for the future. Consciousness gives us the power to shape our own path, making life rich and full of possibilities. One theory that has gained attention is called Panpsychism. This theory suggests that consciousness isn't limited to living things like humans or animals. Instead, consciousness might be something that exists in all things, even in the smallest parts of the universe like atoms and particles. If this is true, then consciousness is everywhere and in everything. When we look at the stars at night, it's easy to feel small and disconnected. But if the universe is conscious, we may actually be deeply connected to it. Just as every part of our body is connected, from our hands to our feet, every part of the universe might be connected through consciousness. This gives us a new way of thinking about the world around us and our place in it. Some thinkers have even suggested that consciousness could be the very thing that creates the universe. They argue that without consciousness, there would be no one to experience the universe, and so the universe might not even exist in the way we understand it. In this view, consciousness and the universe are deeply linked, and one cannot exist without the other. The idea of a conscious universe also makes us rethink time. We often think of time as something that moves in one direction, including past, present, and future. But if the universe is conscious, perhaps time isn't as simple as we think. Some theories suggest that consciousness might exist outside of time in a way that's difficult for us to imagine. This could mean that the universe doesn't experience time in the same way we do, and that consciousness could be timeless. This brings us to an important question. If the universe is conscious, what does that mean for us? Are we just small parts of this larger consciousness, or do we play a more important role? Could our thoughts and actions affect the universe in some way, just as the universe affects us? Some believe that if the universe is conscious, then everything we do and think could have an impact, even if it's in ways we don't fully understand. This might mean that our individual consciousness is part of a much larger network, one that stretches across the entire universe. As we continue to explore this idea, it's important to remember that we don't have all the answers. The conscious universe theory is still just a theory, and we may never know for sure if the universe is truly aware of itself. But thinking about it can help us feel more connected to the world around us and give us a sense of wonder about the universe we live in. The idea of a conscious universe also touches on spirituality for many people. Different cultures have long believed that the universe or the earth is alive in some way, and that everything is connected through a shared energy or spirit. In these traditions, the idea of a conscious universe isn't a new one, it's something that has been believed for thousands of years. As we close our introduction to this fascinating idea, let's take a moment to reflect on the possibility that we are not alone in our consciousness. The universe, vast and mysterious, might be more alive than we ever imagined. And as we think about this, we can let our minds relax, knowing that we are part of something much bigger than ourselves. Whether or not the universe is conscious, thinking about it can bring a sense of peace and connection. Pandora's cluster is a group of stars and galaxies that came together from at least 4 different galaxy clusters after a massive collision in the distant past. In this image, you can see a mix of information. The red color shows X-rays, and the blue areas show where most of the mass is. Interestingly, the blue mass is in places where there's no visible light. That's what we call dark matter. In fact, about 75% of the mass in Pandora's cluster is dark matter. Scientists think dark matter makes up about 27% of the total mass in the universe, and most of the rest is something called dark energy. The strange part is that nobody really knows what dark matter or dark energy is. So, about 95% of the universe is still a mystery, even though we've been studying it for a long time. There are big unknowns at both the smallest and largest scales in the universe. It would be great if all these mysteries were connected by one simple idea, but we haven't found it yet. It's almost like the universe is playing tricks on us. One idea that tries to explain some of these mysteries is called Panpsychism, which suggests that consciousness might be a part of everything in the universe. The basic idea behind panpsychism is simple but also controversial. Everything is conscious, including galaxy clusters and tiny particles, even someone in a coma. It's complicated, but the cells in their body and the molecules in those cells are in some way conscious. What makes panpsychism interesting is how it explains certain mysteries. Maybe dark matter and dark energy don't really exist, and we only think they do because stars and galaxies choose to act a certain way. The same could go for small particles like quarks, electrons, and photons. They might not be so mysterious if they're actually making choices. We can sense a lot of things, including sights, sounds, and smells. Now, of course, small particles don't sense things like I do, but they do have properties like electric charge that interact with their environment. Electrons are attracted to positively charged particles and pushed away by negative ones. You could think of this attraction and repulsion as a type of perception. Since this attraction changes based on distance, it suggests that electrons have a point of view. You could say the same about almost anything that has properties and interacts with other things. This even applies to theoretical objects like magnetic monopoles or the strings in string theory. One of the reasons panpsychism is so appealing is because it offers a way to explain some of the big mysteries of the universe. For example, we know that humans and animals are conscious, but we don't fully understand how consciousness arises. How do physical processes in our brain lead to awareness? Panpsychism offers an answer by saying that consciousness is already present at a fundamental level, even in the simplest parts of the universe. According to this view, consciousness doesn't suddenly appear in complex beings like humans. It's always been there, even in the smallest particles. This idea also challenges the traditional view that the universe is made up of two separate things, including matter and the conscious mind. In the traditional view, these two things are very different, and it's hard to explain how they interact. Panpsychism, however, suggests that matter and mind aren't separate, they're two sides of the same coin. Everything in the universe has both a physical side and a mental side. Now, let's take a step back and think about the universe as a whole. The universe is vast, with billions of galaxies, each containing billions of stars and planets. It's hard to even imagine the scale of it all. Panpsychism asks us to consider the possibility that the entire universe might be conscious in some way. Some people might find this idea strange or hard to accept, but others believe it offers a new way to think about the universe. If everything in the universe has some form of consciousness, then the universe itself might be seen as a kind of giant mind, with different parts of it experiencing different things. This doesn't mean the universe has thoughts or feelings like we do, but it does suggest that the universe is more than just a collection of physical objects. It might have a deeper, more complex nature, something like one that includes consciousness at all levels, from the tiniest particles to the largest galaxies. Panpsychism can also be used to explain some of the biggest mysteries in modern science, like dark matter and dark energy. Scientists believe that dark matter makes up about 27% of the universe, and dark energy makes up about 68%. Together, they account for 95% of the universe. But the strange thing is, we don't really know what dark matter or dark energy are. They don't seem to interact with light or any of the things we can easily observe. Panpsychism offers a different way of thinking about these mysteries. What if dark matter and dark energy don't really exist as separate things, but are instead the result of conscious choices made by stars, galaxies, and particles? In this view, the universe might behave the way it does not because of some mysterious forces, but because the parts of the universe are choosing to act in certain ways. Of course, this is just a theory, and it's not yet backed by scientific evidence. But it does show how panpsychism can offer new and creative ways of thinking about some of the biggest questions in science. One of the most interesting things about panpsychism is the idea that consciousness plays a key role in the universe. In traditional science, consciousness is usually thought of as something that comes from complex brains like ours. But in panpsychism, consciousness is everywhere and is a fundamental part of reality. This proposes some questions. If consciousness is present throughout the universe, could it play a role in shaping how the universe evolves? Could it influence the way stars, galaxies, and planets form? Could consciousness be responsible for the development of life? These are big questions, and we don't have the answers yet. But Panpsychism invites us to think about the universe in a new way, one that doesn't separate mind from matter, but sees them as connected. When talking about Panpsychism, of course, not everyone agrees with Panpsychism. Some people think it's too far-fetched to believe that everything in the universe has consciousness. Critics argue that we don't have any solid evidence to support the idea, and it might just be wishful thinking. They believe that consciousness is something that only arises in complex beings, like humans, and doesn't exist in simple particles or objects. Others argue that even if Panpsychism is true, it doesn't really explain how consciousness works. Just saying that everything has consciousness doesn't tell us how consciousness arises or what it means to be conscious. These criticisms are important, but they don't take away from the fact that Panpsychism offers a new and exciting way of thinking about the universe. It definitely challenges us to rethink some of our most basic assumptions and opens the door to new possibilities. For centuries, people have viewed Earth as a planet full of life. However, the idea that the Earth itself might behave like a living organism is something that challenges our way of thinking. This concept is called the Gaia hypothesis, a theory that suggests Earth is not just a collection of plants, animals, oceans, and mountains, but that it functions as a single self-regulating system, almost like a living being. The Gaia hypothesis was proposed in the 1970s by British scientist James Lovelock. The theory is named after Gaia, the ancient Greek goddess of the earth. His idea was simple, that our planet Earth behaves like a living organism, working to maintain the right conditions for life. According to the Gaia hypothesis, all living and non-living parts of Earth work together to create a balanced, stable environment. This includes everything from plants and animals to the atmosphere, oceans, and even the rocks beneath our feet. The theory suggests that life on Earth doesn't just adapt to its environment, it actively helps shape and control it. In other words, life and the planet are interconnected in a way that keeps Earth habitable. The Gaia hypothesis suggests that Earth has self-regulating systems that work like the body's systems. Just as your body controls its temperature, heart rate, and breathing to keep you alive, the Earth controls things like temperature, ocean salinity, and oxygen levels to maintain life-friendly conditions. For example, let's think about oxygen. Plants and trees release oxygen into the air through photosynthesis, which animals and humans need to breathe. If oxygen levels become too low, it could threaten life on Earth. According to the Gaia hypothesis, Earth's systems, including plants, help regulate oxygen levels to keep them stable. Another example is the temperature of the Earth. Over millions of years, Earth's temperature has stayed within a range that allows life to survive, even though the sun has become hotter. This stability could be due to the Earth's ability to regulate its own temperature like a thermostat. The planet does this through natural processes, such as the absorption of carbon dioxide by plants and oceans, which help to cool the planet when necessary. These are just a few examples of how the Earth may regulate itself, working to keep conditions balanced for life. One of the key ideas in this hypothesis is that living things like plants, animals, and microorganisms, and non-living things like air, water, and soil all work together to create a healthy planet. Each part of the Earth plays a role in maintaining the environment, just like each part of your body helps keep you healthy. For instance, trees take in carbon dioxide from the air and release oxygen. This helps regulate the levels of gases in the atmosphere. Meanwhile, the oceans absorb large amounts of carbon dioxide, helping to reduce the amount in the atmosphere and control the planet's temperature. In this way, life on Earth isn't just a passive part of the environment. It plays an active role in shaping the planet, contributing to the processes that keep the environment stable and suitable for living things. In turn, the Earth's natural systems provide the conditions that allow life to thrive, creating a feedback loop where life and the planet support one another. The Gaia hypothesis suggests that Earth behaves like a living organism, but does that mean Earth is truly alive? According to Lovelock, the hypothesis doesn't claim that Earth is alive in the same way humans, animals, or plants are. Instead, it proposes that Earth functions like a living organism because it is able to maintain its own balance and keep conditions right for life. In this sense, Earth might not have consciousness or emotions, but it does have systems that respond to changes and help keep the planet stable. This hypothesis also reminds us of the delicate balance needed to keep Earth healthy. If Earth is like a living system, then human actions that damage the environment, such as pollution, deforestation, and the burning of fossil fuels, can throw that system out of balance. For example, by releasing too much carbon dioxide into the air, humans are contributing to global warming, which affects the Earth's ability to regulate its temperature. This could lead to changes that make the planet less stable and less hospitable to life. Understanding Earth as a living system can inspire a sense of responsibility. Just as we take care of our bodies by eating well and staying healthy, we need to take care of our planet to keep it functioning properly. This hypothesis helps us see that all life on Earth is connected, and what we do to one part of the planet can affect the whole system. The Gaia hypothesis also highlights the role of life in regulating the Earth's environment. In this view, life is not just a passenger on a lifeless planet, rather it plays an active role in shaping and maintaining the environment. For example, consider the role of phytoplankton in the oceans. Phytoplankton are tiny organisms that live near the surface of the ocean and produce oxygen through photosynthesis. They'd also help cool the Earth by releasing a chemical called dimethyl sulfide, which encourages cloud formation. These clouds reflect sunlight and help regulate the planet's temperature. In this way, tiny life forms in the ocean contribute to the global climate system. Similarly, forests play a huge role in regulating the Earth's climate. Trees take in carbon dioxide and release oxygen, helping to keep the atmosphere in balance. Forests also play a role in the water cycle by absorbing and releasing water, which helps regulate rainfall and maintain ecosystems. These examples show how life on Earth is not just adapting to the environment. It's actively shaping the planet to maintain conditions that support life. In this way, the Gaia hypothesis suggests that life and the environment are deeply interconnected and that both work together to create a stable, balanced system. Another important aspect of the Gaia hypothesis is the role of microorganisms in maintaining Earth's balance. Microorganisms are tiny living organisms, such as bacteria and fungi, that play a crucial role in many of the Earth's systems. For example, in the nitrogen cycle, certain bacteria in the soil help convert nitrogen from the air into forms that plants can use to grow. Without these microorganisms, plants would struggle to get the nutrients they need, which would disrupt ecosystems and food chains. These tiny organisms are an essential part of Earth's life support system, helping to maintain the balance of nutrients in the soil and atmosphere. Microorganisms also play a key role in breaking down organic matter and recycling nutrients. When plants and animals die, microorganisms break down their bodies, returning vital nutrients to the soil. This process helps sustain plant life and supports the entire food chain. In this way, microorganisms are like the Earth's recycling system, ensuring that nothing goes to waste and that life can continue to thrive. These examples show that even the smallest forms of life play an essential role in maintaining the balance of Earth's systems, further supporting the idea that the planet functions as a unified, living system. While the Gaia hypothesis has inspired a lot of people, it has also faced criticism from some scientists. Critics argue that the Earth doesn't intend to regulate itself, and that what we see as self-regulation is just a result of natural processes working by chance. They point out that life on Earth has survived through periods of extreme change, such as ice ages and mass extinctions, which suggests that the planet doesn't always maintain perfect balance. However, supporters of the Gaia hypothesis argue that the Earth's ability to recover from these extreme events actually supports the idea that it acts like a living system. Just as a living organism can survive injuries and heal over time, the Earth has shown resilience in the face of major disruptions. For example, after the extinction of the dinosaurs, life on Earth eventually bounced back and new species emerged, filling the gaps left behind. This shows that the planet has the ability to adapt and continue supporting life, even after dramatic changes. Supporters also point to modern environmental challenges as a reason to take the Gaia hypothesis seriously. As human activity causes changes in the environment such as climate change, deforestation, and pollution, Earth's natural systems are being pushed to their limits. If we understand Earth as a living system, we can see how important it is to protect the processes that keep the planet in balance. In this way, the Gaia hypothesis encourages a more holistic approach to environmental conservation, one that recognizes the deep connections between life and the environment. One of the most common questions people ask when thinking about the universe is, what is the meaning of life? This question has been asked for thousands of years by philosophers and spiritual teachers alike. While there is no single answer that everyone agrees on, it's a question that helps guide our thoughts about who we are and why we are here. Some people find meaning in connection, whether it's connecting with other people, nature, or the universe itself. Others find meaning through personal growth, creativity, or exploring the mysteries of existence. For some, the search for meaning is tied to spirituality, where life is seen as part of a greater whole, often guided by forces or principles that are beyond human understanding. Whether through personal reflection, meditation, or spiritual practices, many people find that thinking about these bigger questions gives them a sense of peace and purpose. In many spiritual traditions, there is the belief that everything in the universe is connected. This idea of onness suggests that all living beings, nature, and even the universe itself are part of a single unified whole. From this perspective, separation is an illusion and everything is deeply linked. This belief is present in various philosophies and religions. In Eastern traditions, such as Buddhism and Hinduism, the idea of unity is central. The concept of Brahman in Hinduism refers to the ultimate reality that is present in everything, while Buddhism speaks of interdependence, where every part of the universe affects every other part. For many, this understanding of onness leads to feelings of compassion and respect for all living beings. It encourages the idea that by helping others, we are also helping ourselves because we are all connected. Another common reflection is about our place in the universe. The sheer size and complexity of the cosmos can make us feel small and insignificant. But at the same time, realizing that we are part of something so vast and incredible can bring a sense of wonder and humility. Some people find comfort in knowing that we are all made of stardust. The same elements that make up stars, planets, and galaxies are also found in our bodies. This connection to the universe reminds us that we are not separate from it, but are deeply woven into its fabric. From a spiritual perspective, this sense of being part of the universe can help us feel grounded, connected, and supported. It reminds us that while life may be full of challenges, we are part of something much bigger than ourselves. Many people also reflect on the idea of purpose. Is there a reason the universe exists? Is there a reason we are here? These are questions that don't have easy answers, but they are central to both philosophy and spirituality. For some, purpose is found through religious or spiritual beliefs, where life is seen as part of a larger plan. For others, purpose comes from within, through personal experiences and choices. This can mean living a life that brings happiness to oneself and others, or it can mean exploring the unknown and expanding one's understanding of the world. The idea of purpose can be as unique as each individual, but it remains one of the most important reflections that shape how we live our lives. Finally, one of the greatest reflections is the mystery of existence itself. Why does the universe exist at all? How did it begin, and what will happen in the future? Many spiritual traditions propose the idea that some mysteries will never be fully understood. Instead of seeking concrete answers, they focus on accepting the unknown and finding peace in the journey of exploration. In philosophy, this approach is often about embracing the mystery and allowing it to spark curiosity, creativity, and deeper inquiry. For many, reflecting on the mysteries of existence brings a sense of awe and wonder. It reminds us that while we may not have all the answers, the search for understanding is what gives life its richness and depth. One of the most interesting reflections comes from the balance between science and spirituality. Science gives us facts and helps us understand the physical workings of the universe, how stars form, how planets move, and how life evolves. But spirituality helps us think about the universe in a more personal, emotional, and reflective way. Some people see these two approaches as opposites, but many find that they can complement each other. Science can show us how the universe works, while spirituality helps us explore how that knowledge affects our sense of purpose and meaning. For example, understanding the vastness of space through science can inspire feelings of awe and humility, which are often central to spiritual experiences. This balance reminds us that while science explains the how of the universe, spirituality helps us explore the why. Both approaches can work together, giving us a fuller picture of our place in the cosmos. A key part of many spiritual practices is the focus on the present moment. This practice is often called mindfulness, where we pay attention to what is happening right now without worrying about the past or the future. It's a way of connecting with ourselves, our surroundings, and the universe in a calm and clear way. Mindfulness can be a powerful tool for reflection. By focusing on the present moment, we can appreciate the simple things in life. The feeling of the air around us, the sound of the wind, the warmth of the sun. These moments remind us that we are part of something bigger and that even in the smallest experiences, there is beauty and connection. In a world where we are often distracted by stress, technology, and the fast pace of life, mindfulness offers a way to slow down and reflect on our connection to the universe. It teaches us that peace and clarity can be found when we focus on the here and now, rather than constantly chasing after what's next. Many spiritual traditions speak of transcendence, the idea that we can move beyond the limits of our everyday experiences and connect with something greater. This concept suggests that there is more to life than what we can see, touch, or measure, and that by opening our minds, we can reach deeper levels of understanding and awareness. Transcendence can take many forms. For some, it's about connecting with the universe in a spiritual way, through meditation, prayer, or reflection. For others, it's about experiencing moments of deep joy, love, or peace that seem to go beyond the ordinary. These moments remind us that there is something special about being alive, something that goes beyond the physical world. In a philosophical sense, transcendence invites us to think beyond our everyday lives and ask big questions. What is the nature of reality? Is there something more to existence than what we experience day to day? These reflections help us explore the universe from a different perspective, one that seeks to understand not just the physical world, but also the emotional and spiritual layers of existence. Many spiritual traditions suggest the importance of being connected with nature. Nature is often seen as a reflection of the universe itself, is beautiful, powerful, and full of life. By spending time in nature, we can connect with the earth, the sky, the water, and the living beings that share our world. For many, nature offers a sense of peace and clarity. The rhythm of the natural world, from the changing of the seasons to the cycles of life, can remind us of our own connection to the universe. In nature, we see the balance of life and death, growth and decay, and the ongoing process of renewal. Some people find spiritual meaning in caring for the environment, seeing it as their responsibility to protect the earth and all its living creatures. This sense of connection and responsibility helps us remember that we are not separate from nature, but a part of it. Another important aspect of philosophical and spiritual reflection is the practice of gratitude. Gratitude is the act of recognizing and appreciating the good things in life, no matter how small. It's a way of focusing on what we have rather than what we lack. When we take time to be grateful, we often realize how much there is to appreciate. Whether it's the beauty of a sunset, the kindness of a friend, or the feeling of being alive, gratitude helps us see the richness of life. In spiritual traditions, gratitude is often seen as a way of connecting with the universe, showing respect and appreciation for the gifts of existence. Gratitude can also shift our perspective, helping us find peace and contentment even in difficult times. By focusing on the positive, we open ourselves to the joy that can be found in everyday life, and we strengthen our connection to the universe and the people around us. Another deep reflection often found in both philosophy and spirituality is the awareness of mortality. The knowledge that life is finite makes many people reflect on the importance of the time we have and how we choose to live it. Mortality encourages us to ask about what legacy will we leave behind. What will our actions mean in the bigger picture of life and the universe? For some, this reflection leads to a deeper appreciation of life and the present moment. For others, it sparks a desire to make a meaningful impact, whether through kindness, creativity, or personal growth. Spiritual traditions often frame mortality as part of a greater cycle of life, death, and rebirth, offering comfort and perspective on the inevitable changes that life brings. Finally, many people reflect on the idea that life is a journey, one that every person and living thing is part of. Whether we think about this in terms of personal growth, spiritual development, or the broader evolution of the universe, life is a continuous process of change and discovery. In this journey, we face challenges, experience joys, and learn along the way. By reflecting on the nature of this journey, we can find a sense of purpose and direction. The idea that we are all part of something bigger, moving toward greater understanding and connection, can give us hope and motivation to keep moving forward. The link between quantum physics and consciousness is another interesting point, where, at the same time, the idea of the universe working like a giant neural network has gained attention. Neural networks are systems of connections, like the ones in our brain, where information flows and changes over time. In this view, the universe could be thought of as a vast network, where everything is connected and consciousness plays a role in this connection. One of the most interesting ideas in quantum physics is the role of the observer. In many quantum experiments, particles don't seem to choose a specific state until they are observed. Before an observation is made, a particle exists in a state of superposition, meaning it can be in many different states at once. But as soon as it is observed, the particle seems to settle into one definite state. This has led some scientists and philosophers to suggest that the act of observation might play a key role in shaping reality. If observing a particle changes its behavior, then perhaps consciousness, the thing doing the observing, is somehow linked to the way the universe works at a fundamental level. This idea opens up questions about whether consciousness could be more than just a product of the brain. The connection between quantum physics and consciousness is still a subject of debate, but some theories suggest that consciousness might arise from quantum processes happening inside the brain. One idea is that the brain might function like a quantum computer, where information is processed using the strange principles of quantum physics. For example, quantum particles can exist in multiple states at once, and they can become entangled, allowing for instant communication between distant particles. Some researchers believe that these quantum effects could be happening inside the brain, allowing for complex thought processes and possibly even consciousness itself. While this idea is still in its early stages, it raises an interesting question. Could consciousness be a result of quantum mechanics? If the brain operates using quantum principles, it might explain why consciousness is so difficult to understand using traditional scientific methods. Quantum physics could offer new insights into how our minds work and how they are connected to the universe. Another idea that connects quantum physics and consciousness is the view of the universe as a neural network. A neural network is a system where many individual units, called neurons, are connected and interact with one another. In the brain, neurons send signals to each other, allowing us to think, feel, and process information. Some scientists and thinkers believe that the universe itself might work in a similar way. Just like the neurons in our brain, the fundamental particles of the universe might be connected in a vast network, constantly interacting and sharing information. In this view, the universe would be like a giant brain, where everything is linked together in a web of connections. This idea is supported by quantum physics, which shows that particles can be entangled across vast distances. These particles remain connected no matter how far apart they are, suggesting that the universe might be more like a network than a collection of individual objects. If the universe is a giant neural network, then consciousness could be one of the key elements in this network. Just as neurons in the brain create our awareness and thought processes, the particles of the universe might work together to create a kind of universal consciousness. This would mean that consciousness is not just something that happens inside our brains, but is instead part of the very fabric of the universe. If quantum physics and consciousness are connected, it could change the way we think about both the mind and the universe. One of the biggest mysteries in science is the hard problem of consciousness, the question of how physical processes in the brain can lead to the experience of being aware. Quantum physics could provide a new way to approach this problem by suggesting that consciousness is not just a result of the brain's activity, but something more fundamental to the universe itself. This raises many questions. For example, if consciousness is linked to quantum processes, does that mean that all particles in the universe have some form of awareness? Could consciousness be a property of the universe itself, spread out across everything, from the smallest particles to the largest galaxies? These are questions that scientists and philosophers are still exploring, and we are only beginning to scratch the surface of what they might mean. While the idea of linking quantum physics and consciousness is popular in some discussions, many scientists are skeptical. Critics argue that just because quantum physics is strange and difficult to understand, it doesn't mean it has anything to do with consciousness. They point out that there is no solid evidence to show that the brain works like a quantum computer or that consciousness arises from quantum processes. In fact, most neuroscientists believe that consciousness can be explained by the activity of neurons in the brain without the need to involve quantum mechanics. According to this view, consciousness is the result of electrical and chemical signals in the brain, and while it is still not fully understood, it doesn't require quantum explanations. As we explore the mysteries of consciousness and the universe, one name of Erwin Schrödinger often comes up. Schrödinger was a physicist best known for his contributions to quantum mechanics, especially the famous thought experiment called Schrödinger's cat. But beyond his work in physics, Schrödinger had a deep interest in the nature of consciousness and how it might connect to the universe at large. In fact, Schrödinger developed a philosophical idea that is still discussed today, known as unified consciousness. This idea suggests that consciousness is not something that belongs to individual beings alone, like humans or animals. Instead, consciousness might be something that is shared by everything in the universe. Schrödinger's theory is an attempt to connect the strange behavior of particles in quantum mechanics with the mysteries of the mind and consciousness. Before knowing about Schrödinger's idea of unified consciousness, it's important to have a basic understanding of quantum mechanics. Quantum mechanics is the science that deals with the behavior of very small particles, such as electrons and photons, which make up the building blocks of everything in the universe. The strange thing about these particles is that they don't follow the same rules that larger objects do. For example, in the quantum world, a particle can exist in multiple places at the same time. This idea is called superposition. Particles can also be entangled, which means that if you affect one particle, it instantly affects another particle, even if they are far apart. This has led scientists to believe that, at a very small scale, everything in the universe is connected in ways that are difficult to fully explain with everyday logic. Schrödinger was one of the early pioneers of quantum mechanics, and he was deeply curious about what these strange behaviors might tell us about reality. But he was also interested in a different mystery, which was consciousness. Now, consciousness is something we experience every day. It's the feeling of being aware, of thinking, feeling, and sensing the world around us. But despite how common consciousness is, we still don't fully understand what it is or how it works. One of the biggest questions in science is how the brain, which is made up of physical cells, produces consciousness. How do chemical and electrical signals in our brains lead to the experience of being aware? This is often called the hard problem of consciousness, and it remains one of the biggest mysteries in both science and philosophy. Schrödinger believed that the answers to this question might lie in quantum mechanics. He had a deep interest in consciousness and its connection to the universe. Schrödinger proposed a theory that challenges the way we usually think about the mind. He believed that consciousness is unified, meaning that there is only one shared consciousness in the entire universe. This idea, known as unified consciousness, suggests that the division we feel between our individual minds and the rest of the world is not real. Instead, Schrödinger argued that the consciousness each of us experiences is just a part of a single greater consciousness that exists across all living beings and possibly beyond. Unified consciousness is a philosophical concept that Schrödinger developed based on his study of both quantum mechanics and ancient Eastern philosophies. The core idea is that the consciousness we experience is not separate or unique to each individual. Rather, it is shared, and all beings are part of one larger, unified mind. In our everyday experience, it seems like we each have our own separate thoughts, feelings, and awareness. But Schrödinger believed this was an illusion. He suggested that all individual consciousnesses are actually connected, like different branches of the same tree. While it feels like we are separate from one another, we are all drawing from the same source. In his view, what we see as our personal thoughts and experiences are just different parts of this one shared consciousness. This doesn't mean that we lose our sense of identity. Instead, it suggests that our awareness comes from a larger universal mind that unites all living things. Schrödinger's idea of unified consciousness was simple but radical. He believed that consciousness is not something that belongs to individual beings alone, but rather, it is something that is shared by all living things. In Schrödinger's view, the consciousness we experience as individuals is just one small part of a much larger, unified field of consciousness that spans the entire universe. In other words, there is only one consciousness in the universe, and every living being is part of it. Schrödinger believed that the idea of separate, individual consciousnesses is an illusion. While it feels like we each have our own private minds, in reality, we are all connected by the same underlying consciousness. This idea of a shared consciousness ties into the principles of quantum mechanics. Schrödinger was especially influenced by the curiosity of entanglement, where two particles can be connected in such a way that changes in one particle instantly affect the other, no matter how far apart they are. Schrödinger saw this as evidence that the universe is deeply interconnected. Just as particles are linked through entanglement, Schrödinger believed that consciousness is also interconnected across the universe. Schrödinger's theory of unified consciousness is deeply connected to his work in quantum mechanics. Quantum mechanics, the branch of physics that studies the smallest particles of the universe, shows us that the world at its smallest levels behaves in strange and unexpected ways. Schrödinger believed that the weirdness of the quantum world could help explain the nature of consciousness. One of the most important ideas in quantum mechanics is entanglement. This is when two particles become connected in such a way that they can instantly affect each other, even when they are far apart. Schrödinger thought that this deep connection between particles might also apply to consciousness. Just as particles are linked together, Schrödinger believed that all consciousness could be connected, forming one unified whole. He also found the idea of the observer in quantum mechanics very important. In quantum experiments, particles don't seem to take on a definite state until they are observed. This suggests that the act of observing, an action that requires consciousness, can influence reality. Schrödinger believed that this connection between observation and reality hinted that consciousness might be more fundamental to the universe than we thought. Schrödinger's ideas weren't influenced only by science. He was also deeply inspired by Eastern philosophies, particularly those found in Hinduism and Buddhism. In these spiritual traditions, there is a belief that all living beings share a common consciousness, and the idea of a separate self is seen as an illusion. In Hinduism, the concept of Brahman refers to the ultimate reality that is present in everything. According to this view, the individual self or Atman is not separate from Brahman, but is a part of it. This idea strongly influenced Schrödinger's belief in a unified consciousness. Similarly, Buddhism teaches that everything in the universe is interconnected and nothing exists independently. Schrödinger saw parallels between these teachings and the discoveries of quantum mechanics. He believed that, Just as quantum mechanics shows us that everything in the universe is connected at a deep level, these ancient philosophies reveal that our minds are connected in a similar way. If his idea of unified consciousness is correct, it means that our experience of being separate, individual minds is not the full story. In reality, we are all part of a much larger whole. Our thoughts, emotions, and awareness come from this shared consciousness, even though it feels like they belong only to us. Imagine a vast ocean. Each individual wave that rises on the surface of the ocean might seem separate from the others, but they are all made of the same water. In the same way, Schrödinger believed that each person's experience of consciousness is like a wave on the surface of a greater unified mind. This doesn't mean that our personal thoughts and feelings are unimportant. Rather, it suggests that we are connected to something much bigger than ourselves. Our minds are like small parts of a larger whole, and when we are conscious, we are experiencing just one aspect of this greater shared awareness. Another key idea in quantum mechanics that influenced Schrödinger's thinking is the role of the observer. In many experiments, particles don't seem to take on a definite state until they are observed. Before they are observed, they exist in a state of superposition where they can be in multiple states at once. It is only when an observation is made that the particle chooses one specific state. This idea, that reality might depend on whether or not it is being observed, has led some to suggest that consciousness plays a fundamental role in shaping the universe. Schrödinger believed that if consciousness plays a role in determining the state of particles, then consciousness might be much more important to the universe than we previously thought. This led him to propose that consciousness is not just a byproduct of the brain, but is a fundamental part of the universe itself. While Schrödinger's theory of unified consciousness is fascinating, it is also met with skepticism. Some scientists argue that there is no clear evidence to suggest that consciousness is shared across the universe. Many researchers believe that consciousness arises from the brain's complex activity and that it is a personal experience that cannot be spread across the universe. Others believe that even if quantum mechanics and consciousness are connected, it doesn't necessarily mean that all consciousness is one. They argue that while quantum mechanics might reveal a new way of thinking about reality, it doesn't automatically lead to the idea of a single unified consciousness. Nothingness, an absolute void, is a concept that challenges the human mind. We often assume that everything must come from something, but how did everything begin? We sometimes claim it started from nothing, but how can nothing become something? In the vastness of the cosmos, where galaxies shine and black holes pull in matter, the idea of nothingness stretches our understanding of the universe. This isn't just a philosophical question, it's a core idea in cosmology that has intrigued scientists and thinkers for centuries. Imagine a region of space completely free of stars, planets, or any form of matter. A quiet stretch of the universe where the usual rules of physics may no longer apply. Though it seems contradictory, nothingness plays an essential role in our understanding of the universe. To grasp the mysteries of the cosmos, we must first understand what nothing means in the context of space. At first glance, the emptiness of space might seem like a perfect vacuum with no matter or energy. While there is some truth to this idea, it doesn't capture the full picture that modern science has revealed. In today's understanding, nothingness is not an empty void, but a dynamic space filled with unexpected activity. Let's dive into this idea through the lens of science. Contrary to what we might think, space is not truly empty. It is alive with quantum fluctuations, where particles and antiparticles briefly pop into existence, only to cancel each other out. This gives the vacuum a constantly changing nature. Even in areas with no visible matter, space is linked to the fabric of space-time, as described by Einstein's theory of general relativity. Massive objects, like stars or black holes, can still bend space-time, affecting how things move around them. When we peer into the depths of space, we can detect the faint afterglow of the Big Bang, the cosmic microwave background radiation. This relic from the early universe reminds us that space has changed over time. Yet, despite our progress, the idea of nothingness remains a deep puzzle, one that both scientists and philosophers continue to ponder. Some theories suggest that there might be parts of the universe where the density of matter is incredibly low, close to absolute nothingness. While these ideas remain largely speculative, they point to the possibility of vast voids in space. If such regions exist, they could help us better understand the true nature of space. Is empty space really devoid of all matter and energy? This question, which seems simple on the surface, leads to a wealth of scientific and philosophical inquiry. Traditionally, we think of space as an empty vacuum, a blank canvas without matter or energy. This fits with our basic idea of emptiness, but the deeper we go into the study of the universe, the more we find that reality is far more complex than we once thought. In quantum mechanics, which explains the behavior of particles at the smallest scales, we encounter another challenge to our idea of nothingness: quantum fluctuations. These suggest that even in the emptiest parts of space, particles and antiparticles can appear, briefly interact, and then vanish again. These momentary events give the void a kind of restless energy, challenging our understanding of what it means for something to be truly empty. Additionally, Einstein's theory of general relativity shows us that space and time are woven together into a four-dimensional fabric called spacetime. Massive objects like planets or stars can bend this fabric, pulling nearby objects toward them. So the idea of a completely empty, untouched space becomes harder to imagine. How does the idea of nothing connect with dark matter, and what does it reveal about the universe's structure? To answer this, we first need to understand dark matter itself. Unlike the ordinary matter that makes up stars, planets, and galaxies, dark matter remains invisible, only making itself known through the gravitational forces it exerts. It represents the ultimate form of nothingness, as it escapes direct observation and doesn't fit traditional definitions of matter. Dark matter's existence was suggested by observing galaxies and their movements. The gravitational pull from visible matter alone couldn't explain their behavior. To account for this gap, scientists proposed the presence of an unseen, intangible substance, dark matter, that fills cosmic spaces and holds galaxies together. The Big Bang Theory suggests that the universe began about 13.8 billion years ago, starting from a singularity, a point of infinite density and temperature. This moment marked the birth of space and time itself, emerging from what might seem like nothing in conventional terms. But how does this explosive start connect with the idea of nothingness? To understand, we must look closer at the nature of the singularity. A singularity represents a state where the normal laws of physics don't apply, a point with infinite density and zero volume, defying our usual ideas of matter and space. In this way, the singularity reflects a form of nothingness, where the universe lacked the familiar structure and dimensions we recognize. However, this nothingness was packed with potential. As the universe expanded from this singularity, it went through a rapid phase of inflation, causing space to stretch almost instantly. This expansion transformed the universe from a state of near nothingness into a space filled with energy, particles, and forces that shape the cosmos as we know it. In the early moments after the Big Bang, the universe was extremely hot and dense, like a thick soup of particles and radiation. In less than a second, it underwent a series of changes, including nucleosynthesis, where the first atomic nuclei came together. This evolution paved the way for stars, galaxies, and the intricate structure of the universe we see today. How do we know the Big Bang happened? There is plenty of evidence supporting this idea. One key clue is the cosmic microwave background radiation, a faint afterglow left over from the early universe. This radiation gives us a picture of the universe as it looked about 380,000 years after the Big Bang, when it finally cooled enough for light to travel through space. In 1965, Arno Penzias and Robert Wilson found this radiation by accident, providing strong support for the Big Bang theory. The even spread of the CMB and its small variations support the idea of cosmic inflation, a period of rapid expansion in the early universe. Another key piece of evidence is the redshift of galaxies. This redshift shows that galaxies are moving away from us, indicating that the universe is expanding. In the 1920s, Edwin Hubble first observed this, and he noticed that the farther away a galaxy is, the faster it moves away, backing up the idea that the universe started small, hot, and dense. However, the Big Bang theory leaves some major questions unanswered. For instance, it doesn't explain what came before the Big Bang or what lies beyond the edge of the observable universe. It also introduces the idea of cosmic inflation, a phase of rapid growth right after the Big Bang, which still puzzles scientists. Before the discovery of the cosmic microwave background radiation, there was another popular theory called the steady-state theory. This theory suggested that the universe has no beginning or end, but stays the same overall, even though it expands, by constantly forming new matter. This idea was well known in the 1940s, but lost support after the CMB radiation was found in 1965, giving strong backing to the Big Bang theory. There are also other ideas, like the cyclic model, which suggests that the universe goes through endless cycles of expansion and shrinking. After the Big Bang, the universe kept expanding and cooling. In the beginning, it was a hot, dense mix of particles. As it spread out, it cooled, allowing particles to join together and form the first atoms. These atoms eventually formed the first stars and galaxies, and the universe's expansion continues today, with galaxies moving away from us in all directions. Going back to the earliest moments of the universe, the first long-lasting particles were protons and neutrons, which formed the nucleus of atoms. These particles appeared around 1/10,000th of a second after the Big Bang. Before this, there was no material in the way we understand it. However, physics allows us to trace the timeline even further back to events that occurred before stable matter existed. To grasp how the universe could begin from nothing, we need to explore the strange world of quantum mechanics. In quantum physics, nothing isn't an empty void, but rather a state of vacuum energy, where particles constantly appear and vanish. This is known as quantum fluctuations. Quantum fluctuations happen in a state called the quantum vacuum, which has the lowest possible energy level. In this state, particles can momentarily come into being and then disappear. According to quantum mechanics, these fluctuations can, in theory, lead to the creation of a universe. So, in this context, nothing is an energetic state that has the potential to bring matter and energy into existence. A key idea here is Heisenberg's uncertainty principle. This principle states that certain pairs of physical properties, like position and momentum, cannot both be measured with complete accuracy at the same time. This principle allows particles to briefly pop into existence from the vacuum as long as they disappear quickly enough to respect the law of conservation of energy. These quantum fluctuations cause particles to appear and vanish shortly afterward. While this might sound strange, such particles have been observed in many scientific experiments. The vacuum of space is filled with particles constantly being created and destroyed, suggesting that the quantum vacuum is not truly empty. But where did space-time itself come from? To answer this, we need to look back to the very beginning of the universe into a period called the Planck epoch. This phase occurred so early in the universe's history that our current theories of physics stopped working. It happened only a tiny fraction of a second after the Big Bang. During this time, space and time were affected by quantum fluctuations. Usually, scientists rely on quantum mechanics to explain tiny particles and on general relativity to explain the large-scale structure of the universe. But to understand the Planck epoch, we need a theory that combines both, something known as quantum gravity. We don't have a complete theory of quantum gravity yet, but there are ideas like string theory and loop quantum gravity. These theories suggest that what we experience as space and time may come from deeper, microscopic processes. The space and time we're familiar with are the result of these quantum processes, which are difficult for us to understand because we live in a world of large-scale objects. Quantum fluctuations occur constantly, even in what we consider to be empty space. According to the Heisenberg uncertainty principle, pairs of particles and antiparticles can appear from the vacuum, exist for a brief moment, and then cancel each other out. This process is sometimes called quantum foam. However, quantum fluctuations alone don't explain the vast scale and complexity of the universe. There is also dark energy, a mysterious force that fills all of space and speeds up the expansion of the universe. While we don't fully understand dark energy, it seems to play a key role in the creation and growth of the cosmos. So, how did we get from quantum fluctuations and dark energy to the universe we see today, filled with galaxies, stars, and planets? The answer lies in inflation, a period of rapid expansion that took place fractions of a second after the Big Bang. During this brief time, the universe expanded at an incredible rate, setting the stage for the formation of everything we observe today. In the Planck epoch, our normal understanding of space, time, and cause and effect breaks down. Despite this, all the leading theories of quantum gravity suggest that something physical was happening during this period, some quantum process that led to the space and time we know. But where did this come from? That remains one of the universe's most profound questions. Even though causality might not function in the way we typically understand, there is still hope that parts of the Planck epoch universe could explain other parts. Unfortunately, our current understanding of physics cannot yet provide clear answers. Until we develop a complete theory of everything, we won't be able to give a definite explanation. What we do know for certain is that no confirmed instance of something emerging from absolute nothing has been found. In this context, the idea of nothingness becomes more dynamic and complex. It is not a simple, empty void, but rather a canvas where the universe paints its story. A story that began with the explosive birth of the cosmos. One of the key questions in advanced cosmology is whether the vacuum of space is truly empty or whether it still contains particles or fields. At first glance, we might imagine space as a vast, empty expanse with no matter or energy. Yet, when we dive into the strange world of quantum mechanics, we discover something surprising. Space is not as empty as it might seem. Quantum mechanics, which explains how particles behave on the smallest scales, shows us that space is full of activity even in what we think of as emptiness. The vacuum of space is not silent, it's alive with quantum fluctuations. These fluctuations are like tiny ripples on a calm pond, appearing at the subatomic level. In these fluctuations, particles and their opposites briefly appear, interact, and then disappear again, creating a fleeting dance of existence. These momentary events challenge our classical view of emptiness, revealing that the vacuum is constantly shifting and changing. In addition, the vacuum of space is not just an empty background, but plays an essential role in the universe. It hosts fields that control the fundamental forces, such as the electromagnetic field. These fields stretch across space, even in regions we think of as empty. In advanced cosmology, we learn that the vacuum is far from a simple void. It is a lively space, filled with quantum fluctuations and fields, blurring the line between nothing and something, and forcing us to rethink what emptiness really means. This idea also has real-world implications. Scientists have found ways to use the energy within these quantum fluctuations in a phenomenon called the Casimir effect. When two parallel conducting plates are placed very close together in a vacuum, they experience a small but measurable attraction due to the changes in the quantum fluctuations between them. This effect, though tiny, shows that the concept of nothingness in space can have real and measurable consequences. To truly answer how something could arise from nothing, we first need to explore several different interpretations of nothing. This interpretation describes a state where the essential building blocks of everything we see are absent. Imagine a universe without galaxies, stars, planets, or humans. Everything we interact with is made up of tiny subatomic particles, the fundamental components that shape the universe. Starting with a universe full of matter, we understand how it grows, cools, and becomes influenced by gravity, eventually forming the universe we know today. Stars live through cycles, creating heavier elements that lead to new stars, planets, and life. But one of the biggest questions in science remains: how did we end up with a universe dominated by matter, rather than equal amounts of matter and antimatter? This is one of the great unsolved mysteries in physics. The universe is almost entirely made of matter, with hardly any antimatter. So, How did we end up with this imbalance of matter? This puzzle is called baryogenesis, the process that created more baryons than antibaryons in the early universe. While there are many theories, we still don't have a clear answer as to why matter dominates over antimatter. Our second interpretation considers nothing as the emptiness of vast space. If you think of nothing as having no things at all, then the first interpretation, where particles are just missing, doesn't fully capture this idea. To understand this concept of nothingness, we need to imagine removing every single particle and all energy from space. If we manage to strip away all matter and energy, what remains is the empty expanse of space. No particles, no matter, no radiation. This is what some scientists regard as true nothingness. However, space-time itself, shaped by general relativity, still exists. The speed of light and the gravitational constant remain the same. There is also something called zero-point energy. Even in the most empty space, a small amount of energy remains. Today, we associate this with dark energy, which causes the universe to expand. But even in this extremely empty scenario, some fundamental elements remain. The laws of physics still exist. Quantum fields, such as the electromagnetic field, gravitational field, and Higgs field, are still present. So, even without matter or radiation, this version of nothing still gives rise to an intriguing universe. It's fascinating to realize that even in the absence of all the things we can see, the universe remains a lively and dynamic place. The third interpretation of nothing considers it as the lowest energy state possible. Right now, our universe has what's known as zero-point energy, a small amount of energy that exists everywhere in space. We don't know if this zero-point energy represents the absolute lowest energy possible, or if there could be an even lower energy state waiting to be discovered. We might be living in a false vacuum, with the true vacuum, the absolute lowest energy state, still out there. If the universe shifted from this false vacuum to a true vacuum, it could trigger a catastrophic event known as vacuum decay. This would fundamentally change the universe. Light particles would gain mass, the electromagnetic force would become limited to short distances, and most of the sunlight would no longer reach Earth. Thinking of nothing as the ultimate lowest energy state means imagining a scenario where all matter, energy, radiation, and any warping of space-time have been removed. What remains is a state of pure emptiness, though the laws of physics would still be present. In this state, it would be impossible to create work, energy, or particles. However, some would argue this still isn't truly nothing because space-time and the rules of physics still exist. It would be like a stage with no actors or plot, just an empty backdrop. So, our third interpretation of nothing is the ultimate lowest energy state possible for the universe. Even in this state, the structure of space, time, and the laws of physics remain intact. It's another incredible mystery that keeps scientists searching for answers. Fourth interpretation of nothing. This is the most extreme interpretation of nothing. It suggests that true nothingness only happens when the entire universe and the rules that govern it completely disappear. This idea goes beyond anything we usually understand. Imagine removing everything including space, time, and even the laws of physics. This kind of nothing cannot be defined by the rules of physics because it represents an absolute void, a total absence of everything. From a scientific perspective, this concept is hard to grasp. How could space-time exist without space or time? How could the laws of physics operate without a structure for them? This version of nothing is difficult to imagine and may not have any real-world meaning. Thinking about this kind of nothingness raises many questions without clear answers. For instance, how could space and time begin from a state where they don't exist? Is it possible to have something without space or start without time? Picture an absolute void known as a complete nothingness. From a physics viewpoint, it hints at a state beyond space and time from which the universe and its rules might have emerged. However, it's unclear if this idea is meaningful or just a product of our imagination. This concept introduces difficult questions. How could space and time begin in a place where neither exists? Could something exist outside the universe or start without time? Where would the rules that control particles and their interactions come from? While this idea of nothingness seems complete, it may not have any real substance. It might simply be a way for us to think about things that are beyond our experience. When scientists talk about nothing, they often assume that everyone shares the same idea of what it means. But that's not always the case. Different people and contexts can shape how we understand nothing. While theories about nothing are grounded in scientific studies, the study of the cosmic microwave background radiation or the faint afterglow of the Big Bang provides key insights into the conditions of the early universe. Precise measurements of the CMB have given us a better understanding of the age, makeup, and structure of the universe. Observations of the expanding universe, as described by Hubble's law, support the idea that the universe began from a hot, dense state. The discovery of dark matter and dark energy, which make up most of the universe's mass and energy, also shows that our understanding of the universe is still incomplete. The phrase "something from nothing" might refer to creating something entirely new where there was truly nothing before. But not everyone agrees on what nothing really means. So, it's important to clarify which version of nothing is being discussed. Black holes are among the strangest objects in the universe. They are regions where matter has been compressed to such an extreme degree that the gravitational pull becomes so strong that not even light can escape. Black holes are often thought of as ultimate voids, giving a new dimension to the concept of nothingness. At the heart of a black hole lies a singularity where density becomes infinitely high and the rules of physics as we know them no longer apply. This singularity can be seen as a counterpart to the nothingness that may have existed before the Big Bang. While black holes form from the remains of massive stars, the absence of matter within them and their powerful gravitational fields make them fascinating subjects when considering the universe's formation from nothing. Black holes form when massive stars use up their nuclear fuel and collapse under their own gravity. This collapse leads to a supernova, leaving behind a dense core that can become a black hole. Black holes play a significant role in the evolution of galaxies and the broader cosmos. They are often found at the centers of galaxies, including our own Milky Way, where they influence the motion of stars and gas. Supermassive black holes, with masses millions or even billions of times greater than the Sun, shape the dynamics of their host galaxies. The interactions between black holes and their surroundings provide important insights into the formation of cosmic structures, helping us understand how the universe evolved from a state of apparent nothingness. The idea of nothingness has been a subject of philosophical thought for centuries. Philosophers have long debated the nature of existence and the possibility of a state without anything. In cosmology, nothingness refers not only to the absence of matter, but to a state where space and time themselves do not exist. This idea challenges our everyday experiences and pushes the boundaries of human understanding. Some philosophical viewpoints argue that nothingness is impossible, as the concept itself suggests the potential for something to exist. Others suggest that the universe's emergence from nothingness highlights the complexity of reality, where even the absence of things can lead to everything we observe. Science also explores nothingness, often intersecting with philosophical ideas, particularly when discussing the origins of the universe. In physics, nothingness can be described as a quantum vacuum, where particles and antiparticles appear and disappear constantly. This dynamic vacuum challenges the traditional idea of an empty void, suggesting that even space is full of potential activity. Theories like quantum field theory and quantum mechanics describe the probabilistic nature of particles and their interactions. The possibility that the universe could emerge from a quantum vacuum supports the idea that nothingness is not a static state, but one filled with potential for creation and transformation. The implications of nothingness reach beyond theoretical physics and cosmology. Understanding how the universe might emerge from nothingness can change our views on existence, creation, and reality itself. It challenges the conventional distinction between something and nothing, showing that the potential for existence may be embedded in the very nature of reality. This realization can also have profound philosophical and existential effects, influencing how we see our place in the universe and what existence means. Additionally, studying how the universe began from nothingness can drive new discoveries and innovations as we continue to unravel the mysteries of the cosmos and our beginnings. The concept of nothing has changed significantly over time, reflecting advances in both scientific and philosophical thought. In ancient times, nothingness was often associated with a complete void, without matter, energy, or space. However, as our knowledge of the universe grew, the idea of nothingness became more complex. Quantum mechanics introduced the idea that even in a vacuum, particles and antiparticles could appear and disappear, showing that nothing is not truly empty. This new understanding has important implications for how we think about the origins of the universe, emphasizing the dynamic nature of what we once considered a static void. As we explore the universe, our understanding of nothingness continues to evolve. The discovery that the universe is expanding, made by Edwin Hubble in the 1920s, revolutionized cosmology. This finding suggested that the universe had a beginning, which emerged from a singularity. This led to the development of the Big Bang theory, which describes how the universe began as a hot, dense point and has been expanding ever since. This theory suggests that before the Big Bang, there was a state of nothingness from which everything emerged. The idea that the universe could come from a quantum vacuum challenged traditional views and opened new paths for understanding the nature of reality. Revolutionary insights into nothingness have come from various areas of science, especially quantum mechanics and cosmology. One key idea is quantum fluctuations, which occur even in a perfect vacuum. These fluctuations cause temporary changes in energy that create particles and antiparticles, providing a possible explanation for how the universe could emerge from nothing. Additionally, the concept of cosmic inflation, a rapid expansion that took place right after the Big Bang, helps explain how quantum fluctuations may have grown into large-scale structures like galaxies. These insights have reshaped our understanding of nothingness, showing that it may be the starting point for the universe itself. The discovery of the cosmic microwave background radiation in 1965 by Arno Penzias and Robert Wilson provided key evidence for the Big Bang theory. The CMB is the faint afterglow of the Big Bang, filling the universe and giving us a glimpse of the cosmos about 380,000 years after its beginning. The uniformity of the CMB, along with its tiny temperature variations, reveals the early structure of the universe, supporting the idea that it started from a hot, dense state and expanded over time. This discovery was crucial in confirming the Big Bang model and advancing our understanding of how the universe could arise from a state close to nothingness. The concept of nothing is inherently puzzling, as we tend to think in terms of things that exist or don't exist. The idea of nothingness challenges the way we normally understand reality, forcing us to explore the limits of our thinking. In cosmology, this puzzle is seen in the idea that the universe could emerge from a quantum vacuum, a state that is not truly empty but filled with potential. The difficulty lies in reconciling the presence of the universe with the idea of a prior state of nothingness. This tension drives both scientific inquiry and philosophical debate, pushing us to refine our ideas and expand our knowledge. Quantum fluctuations in the vacuum offer an intriguing view of how the universe might have emerged from nothing. In quantum field theory, even in what seems to be a perfect vacuum, particles and antiparticles constantly appear and disappear due to energy fluctuations. These fluctuations are not random. They follow the principles of quantum mechanics, which allow for temporary shifts in energy. This active vacuum can give rise to a range of phenomena, including the formation of the universe. During the universe's early moments, these fluctuations were amplified by a period of rapid inflation, leading to the creation of matter and energy from what was once considered empty space. This process shows that what we think of as nothing is actually a dynamic space full of quantum activity capable of bringing the universe into being. Philosophically, nothingness has long been a subject of deep thought and debate. The idea challenges our basic understanding of existence and reality. In classical philosophy, nothingness was often seen as an absolute void, lacking matter, space, and time. However, modern physics has complicated this view by suggesting that nothingness may not be truly empty, but instead full of quantum potential. This shift challenges our understanding of what it means for something to exist, implying that even when matter and energy are absent, the universe still has the potential for creation. These reflections encourage us to rethink the nature of reality and the limits of our knowledge. Human senses are naturally limited when it comes to perceiving nothingness. Our senses detect matter and energy, such as light, sound, and heat. The concept of nothingness in physics often goes beyond what we can directly experience. For example, quantum fluctuations and the cosmic vacuum cannot be sensed directly but are inferred through advanced instruments and mathematical models. This gap between our intuitive understanding and scientific reality highlights the need for sophisticated tools and abstract thinking to understand concepts that lie beyond our everyday experience. Quantum phenomena present significant challenges to our understanding of nothingness. Quantum mechanics reveals that particles can exist in more than one state at the same time and can interact across great distances. These phenomena defy classical ideas of cause and effect, making it difficult to grasp how the universe could begin from a state of nothingness. The idea that quantum fluctuations could lead to the creation of the universe requires us to align these phenomena with the idea of a vacuum. This complexity highlights the challenges of quantum mechanics and its role in shaping our understanding of the cosmos, pushing both science and philosophy to their limits. Cognition and abstract thinking play a key role in our efforts to understand nothingness and the origins of the universe. Human thought is well suited to dealing with concrete experiences, but struggles with abstract concepts like the emptiness from which the universe might have emerged. Theories about quantum fluctuations and nothingness require a high level of abstract thinking and mathematical reasoning. These tools allow us to create models and ideas that go beyond what we can directly observe. The development of theories in cosmology and quantum mechanics relies heavily on this kind of advanced thinking, reflecting the limits of our natural understanding and the need for intellectual tools to explore the origins of the universe.